Oh, that's gonna be too loud. I never adjust my audio. Stupid. Okay, anyway. Eldritch, congrats on redeeming the first. JC. You got robbed. The way it's just below the chat box. You won't be able to see the first redeem now that Eldritch got it. But there's like a channel points redeem for first. It goes away once someone claims it for the stream though, so you won't see it now. Hey mouse. Yep, that's what we're doing. I think I should get rid of some of my redeems. I think I have just like a lot of them. But I don't know. Cranberry banana salad, hello. Welcome in. Oh, wait. I'm just making sure I'm live on YouTube. Okay, I am. Okay. So until we get a question, my plan for the downtime of the stream here was to try and read through this paper. Oh my god. That's a crazy looking figure. Oh wait, I think I'll be able to figure out what this is though. Oh my god. Is that a cube? No, it's gonna be a graph, like a graph in the math. Well, I don't know. It's like a directed graph, but it's not a 3D shape. It's isomorphic to a cube graph. Oh, you know, it actually is. I can see the cube now. Transferring my tragic bad tram. Oh yeah, Eldritch. Yeah, you transferred your bad luck to JC now. How are the top firsts looking these days? Spetry's still king. Then Jed, then Joseph, the other Joseph, Eldritch, and then Zach. Not bad. Okay, so I guess let's start reading. Although targeted therapy is yielding promising results in the treatments of cancers, drug resistance poses a problem. We develop a mathematical framework that can be used to study the principles underlying the emergence and prevention of resistance in cancers treated with targeted small molecule drugs. We consider a stochastic dynamical system based on measurable parameters such as the turnover rate of tumor cells and the rate at which resistant mutants are generated. Now, I assume they're not creating X-Men. Although that would be cool. Oh, okay. So yeah. So this is still, I assume, the cell as a result of a mutation, staying resistant mutants. So the cancer is mutating to be resistant. Okay. We find that resistance arises mainly before the start of treatment and for cancer with high turnover rates. Is this just like how quickly the cells live and die? Combination therapy cells likely yield advantage over single drug therapy. Apply the mathematical framework to chronic myeloid leukemia. Early stage chronic myeloid leukemia was the first case to be treated successfully with the targeted drug, imatinib. Hey, Sage. This drug specifically inhibits the BCR-ABL oncogene, which is required for progression. Although drug resistance prevents successful treatment at later stages of disease, calculations suggest that within the model assumptions, a combination of 3 targeted drugs with different specificities might overcome the problem of resistance. So I'm gonna need to Google the biology words that they're using here. Yeah, okay. It's basically just the process of new cells replacing old ones. So that was the abstract. This actually, I was a little bit afraid. So this is like a homework assignment for me. I was a little bit afraid that language would be too academic. So far, it's not. It's pretty understandable. It's homework. That's the motivation. There was a choice of many academic papers where I could find my own if I wanted to, but I have to answer these questions. It's for a computational biology class, so like the intersection of math and biology. Dr. L. It took me a second to realize what gamma of 7D is. Yeah, 69 factorial. Doing good. I'm tired, but doing good. How about you? I just spotted a script N here. That's the first time I've seen a script N, I think. Okay, drug resistance is a frequent clinical problem for cancer patients. Studying calculus, you're doing pretty dang fantastic. Nice. Are you going to be teaching a calculus class? Many mechanisms of drug resistance have been found. For example, drugs can be prevented from entering the cells. Drugs can be pumped out of cells. Be enzymatically inactivated. Inactivated? Huh. It's a curious use of the word, but I think I understand it. Tutoring. Nice, nice. Hey, fun case. Maybe? This the paper's about drug resistance in cancer. I'm completely there's going to be a pretty big math component to this paper, but obviously it's mostly like about oncology, and I'm completely ignorant of that side of it. So if there's such a thing as an enzyme chain, I honestly don't know. I'd have to Google it. Enzymes break down drugs. That's what it sounds like, or at least I would expect to hear the word deactivated. What's the difference between deactivated and inactivated? I don't know. Actually, you know, let's Google it. I guess. Molecular maestros of life. I'm reading this for current school. This is a homework assignment. And so I'm like it's about the part of biology that like involves like modeling and like the math part of that stuff. But so far they've made zero effort to actually teach the biology. So I'm just kind of Googling things as I encounter them and learning it on the fly. So I guess they say inactivate enzymes because inactive is just a state that commonly describes enzymes, I guess. Hey, Fembucks. Professor that did computational biology, lots of good stuff there. Yeah, this is a class I'm most excited to take. It's going to be kind of annoying / difficult to learn the biology stuff, but I think it'll be worth it. Yeah, yeah. The enzymes... That's true, yeah. The drug is being inactivated by enzymes, which... Okay, well, I'm just gonna move on. I understand at a basic level what's happening with that. There's probably something more advanced that I'm missing, but that's not the point of what we're doing right now. Drug activity can be prevented by mutation or altered expression of the target, and defects in apoptosis, apoptart, senescence. What the? They're just making up words. And repair mechanisms can contribute to resistance. All right, can I get through one sentence without having to Google something challenge? Apoptosis. Apoptosis. Controlled cell death? Oh, okay. Programmed cell death. Okay. Okay, yeah. Same as the mechanism of action? I think so, yeah. So defects in controlled cell death and aging and in repair mechanisms can contribute to resistance. So this is of the cancer cells. Okay. A particular problem in cancer is the occurrence of multi-drug resistance. Many anti-cancer drugs cause direct damage to DNA, which triggers cellular checkpoints. Okay, well, I almost got through that sentence. Okay. Oh my... I fucking hate when websites have stuff like this. Where I see the thing that I want and then a trillion pop-ups. Fucking Khan Academy. Yeah, exactly. Huh. Okay. That's kind of crazy. That's like cells have the ability to like decide whether it's a good idea to divide right now or not. And they can gauge it based off whether their neighboring cells are growing. Wow. So it has to get through multiple check. Okay. So I thought if it went through G1, it would just start dividing. G1, then S, then G2, then M is the actual division. Well, what's S? Didn't we just skip over S? That's the spindle, I guess. Which we'll read about third for some reason. Okay. Why? I don't know why they're showing it out of order like this, but okay. Oh, hey, there's apo to apo. Can't fucking say that. Okay, wait. Usually Google has a thing that will pronounce it for you. I need my Google lady. Usually there's like some audio button on the right or something. Apoptosis. Okay. Wait. Oh. Apoptosis. Okay. Apoptosis. Did I get everything I need from this? Yeah, I figured that out now, coded. I just wanted to know the pronunciation. M checkpoint is also known as the spindle. Wait, so what the fuck is this S then? You have an S in the diagram and you never explain it? Am I just dumb? Okay, fine. I guess they don't want to explain it, I guess. The spindle checkpoint is the M, confusingly. Bio is too hard. Yeah. Yeah. Cell replicates DNA? Okay. Hmm. Counter thing with making at least 2 more questions, I think, is the equation. Yeah. That's really true fun. 1 step forward, 2 steps back. Okay. So that was that sentence. So don't worry. We only have 6 pages of paper to get through. So I'm sure we'll get through it by the end of next week. Oh, yeah. If you want to ask a few questions, go ahead. I want to do like an entire test or something, but if you want to choose like 2 to 3 or something. Or I guess, potentially a few more if they're like some of if they're like the shorter ones as well. You never learned any goofy Kentucky math? Oh, I mean, were you not here when we were doing Goated's questions last time? It's Goated is studying for / doing Kentucky high school competition math. And so we did a good handful of questions last time I streamed math. So I that's like the one type of competition math I can actually do. But yeah, just let me know once you post some stuff, and I'll be happy to answer those. In recent years, however, there's been a transition away from classic cytotoxic and hormonal agents towards targeted therapy. I don't know what cytotoxic means, but I don't think it's that important. This involves the correction of precise molecular abnormalities that underlie the progression of the tumor. An example is the treatment of chronic myeloid leukemia with imatinib. Hey, Adia. Although such therapies have shown remarkable clinical success, the emergence of drug resistance poses problems, especially at more advanced stages of cancer. To manage this problem, it is important to gain an understanding of the principles that underlie the emergence of drug resistance. This requires a mathematical framework. Hey, shout out. The context of viral infections such as HIV, mathematical analysis of the evolution of drug resistance has contributed to devising the combination therapies that now successfully prevent pathology over long periods of time. Okay, now what is pathology? I've heard the word, I don't actually know what it means. Study of disease. Why are we preventing the study of disease? Oh wait, I get it. We aren't prevent the No. Just a disease in general. Yeah, that feels like that's what they're actually saying. Based on the context, I would think that they're saying like we're preventing the disease from taking a hold over a long period of time. It's just a it's just weird, I guess. Yeah, this paper is written like, even though like obviously I don't know the biological terms, but it's not overly academically written so far, which I appreciate. It is supposed to get more mathematical here. Like the point of this paper is like model stuff. We have to get through the beginning part before we can get to the actual math. I see an exclamation point. Look at that. Oh, okay. Let's see. 1, 3, and 4. And these are the questions I have to answer about the paper. But we will come back to that. What is the factorial of therapy? You have to remove one letter at a time. Journal++ does not behave well with images that are too big to... If I zoom out, it's fine. Oop. Okay. So 1, 3, and 4. Find the argument of the complex number... What? Oh, I'm on box. No more box. Of that complex number. Okay. So... Is this DeMoivre's? DeMoivre? For the power of a complex number? Yeah, okay. So it's not that hard to find this formula for yourself if you know Euler's formula, but the thing that they want you to use for the first one is this here. Actually, let me screenshot that just so we can see it at the same time. Bring it down here. Root 2 and 7/8. So it's to the fifth? Yeah, to the fifth. Okay. So, if you don't care to remember DeMoivre's formula, one that you should remember for sure is Euler's formula. E to the I theta is cosine theta plus I sine theta. And if you also know the polar form of a complex number, z equals r e to the I theta, these are the two ingredients you need to find DeMoivre's formula for yourself. Because you can take this equation and raise each side to the power of n. And then this n on the outside can be distributed to each of the two factors inside the parentheses. So r to the n, e to the I n theta. And then we can apply Euler's formula to this piece here to get DeMoivre's. Oh. So if you don't care to memorize things, it's not that hard to get DeMoivre's, just like deriving it again. But either way you want to do it, yeah, exactly. I feel like I was calling you goated today, but I feel like I should be calling you almond. Should. Global Cauchy? No. Oh, it's not. If I did, not by that name. That doesn't sound familiar, at least. Maybe. Global Cauchy. Hey Mo, how's it going? I did. It's been a long time for me, but I did take a discrete math class. I assume it's not Cauchy's integral theorem. I don't think so. This isn't very easy to read. I don't know what's happening in that equation. Convex Cauchy theorem, Cauchy-Gorsat, and there's global Cauchy. I wonder if it'd be in this article. Nope, the word global is not in that. Yeah, I mean, to be honest, the discrete math was one of the classes I had the hardest time with. I'm not very good at that type of math. Yeah, I don't think I've seen it, as far as I can tell. Okay, so you could just go straight to knowing that this 5 is going to be multiplied inside each of the parentheses here, but if I show every step in painful detail here, I'm going to rewrite the inside to be root 2 e to the I 7 pi over 8, just like using Euler's formula but the other direction, just to like be really explicit about what's happening here with the 5 going to each of the two things. If I was like doing this during the competition and you only have like a minute per question or whatever, I would just go straight to this next step, which is you have root 2 to the 5th times cosine 7 pi over 8 times 5 plus I sine 7 pi over 8 times 5. Yeah, it is. And we only need the argument of the complex number, so really I didn't have to do all this. I just needed to know that it'd be 7 pi over 8 times 5, which is 35 pi over 8. That's really like all we needed. Why isn't that an option? Am I stupid? Oh wait, we yeah, there's an extra step. It's high school competition math. So it's not this isn't regular high school math. What's n argument? I'm not sure what you mean by that, Alman. N is just whatever power we happen to be raising the number by. And with complex numbers, it that ends up being multiplied inside of the argument. Oh, what is an argument? Oh, I need to back way the hell up then. I didn't realize you didn't know that. Okay. Uh, okay, so the normal way that we talk about complex numbers when you first introduced to them is that they look like a plus ib, or like so an example of that might be like let me choose a convenient one. Root 2 plus I root 2, let's say. Is that a good idea? Wait, I didn't choose. No, that's fine. I'm going to do divided by 2, though. There we go. So if we go to graph this number in the complex plane, I'm choosing this for a reason. These are about like a 0.7. The actual exact spot isn't all that important. 1, 1, I'll say 0.7 is somewhere around there. We can talk about them regular old, like basically these are Cartesian coordinates going to the right by root 2 over 2 and then going up by root 2 over 2. Or we can talk about the polar form, which is the distance from the origin, which could be called r, or the modulus, and the angle it makes with the positive real axis, theta, which is also the argument. So yeah, and so you're seeing now why I chose this specifically, because it's on the unit circle, so it'll be easy to find the angle here. So Don Al-Gaib underscore. It's a good one. It's a neat proof of holomorphic preserving arguments. Oh, interesting. Also, arg is used to define the winding number. Oh, yeah. And so, because this is on the unit circle, we can also put this in polar form. The polar form of a complex number is r e to the I theta. It's the exact same thing as a plus ib, just a different way of showing it, or like a different, it just looks different, but it's completely equivalent. And sometimes it's more convenient to use. So like you pointed out, this is on the unit circle. So the distance from the origin r is just 1 because the unit circle has radius 1. And then the argument, theta, the angle it makes with the x-axis, if you know your unit circle, well, that one corresponds with pi over 4. Hey, Rushback. And so importantly, the argument is always between 0 and 2 pi. Because I could technically have said e to the I, what would it be? 5 pi over 4? No, 9 pi over 4, right? It's like this is pi over 4 plus 2 pi. But we all kind of agree to restrict it between 0 and 2 pi, usually. Exactly that, yeah. E2 pi mentioned, yeah. Shout out. So yeah, that's exactly what the argument is the angle of the hypotenuse. And so they gave us the complex number with the cosine plus I sine theta, so they really just gave us the argument straight up, except for we have to deal with the power. So as soon as we figure out like how to deal with the power of 5 that was on the outside, we can just read what the argument is straight off like either of these thetas in the problem at hand. So that's what I was doing up here. I got messed up though because I forgot 35 pi over 8 isn't between 0 and 2 pi. So we have to fix it. So what I'm going to do is take 35 pi over 8 and subtract off 2 pi, which is 8 pi, I guess 16 pi over 8. That's 9 pi over 8? No, oh my god. 19 pi over 8. So I'm going to have to subtract it off again. So we get 3 pi over 8. And that was answer A. Answer D looks wild. I don't know how you would get answer D by accident. It is A. Awesome. So yeah, I hope that makes sense. I mean, if you have any other questions about that first one, then we'll move on to 3. I have an exam on Monday for complex. Do I have exercises using Cauchy theorem for convex sets, Moreira's theorem, maximum principle, orthogonality principle, open mapping theorem? Not specifically like I would hesitate to give you any problems from my book because it's so like applied. Anders did send me a while ago a complex analysis book that's in Spanish that I know he likes and that you might also like more. I could send you that if you wanted to have like a look through it for yourself. I can show it on stream so you can see if you already have it or not, but that's what's kind of like coming to mind right now because I don't really have anything like that offhand. Let me see. It's this book here. I can find you on Discord and send it to you right now. But yeah, that one's supposed to be a lot more like theoretical and probably more suited to the stuff that you're doing. So on Discord, you're Kevin. You found it? Okay. Well, I'm gonna hit enter anyway because I already made the message. But so you might be able to find something helpful from there. That's kind of the best idea that I have though. Oh, nice. Oh yeah, underscore. If you have something, please feel free to toss it in there. Multiplied the theta by 5, kept on subtracting. Yes, I took theta, I multiplied it by 5 because that's what the power was that they gave us. And then I got messed up because I thought 35 pi over 8 is the answer. But the argument always has to be between 0 and 2 pi. And so the procedure is you keep on subtracting off 2 pi until you're within that range. Measure theory? No, I never have. That would be like a Zach or Slim thing, I would think, but I know it was Zach. He doesn't feel like very strong in it. I don't know how Slim feels about it. I'd be interested to learn about measure theory one day, but I never have. Hey, Slim. Speak of the devil. And hey, Syntax. It's going well. It was pretty freaking tiring, but it's pretty interesting so far. But yeah, so what's happening with like the 2 pi thing is it, like you can express the same angle on the unit circle in infinitely many ways because let me just bring up an image of the unit circle. So 2 pi is one complete revolution around the unit circle. If you go all the way around, you have gone through an angle of 2 pi. Um, and so what that means is we can express any of these angles we want here in infinitely many ways, because I could start at 0 degrees and go up to pi over 4, or I could start at 0, I guess, radians or degrees, go all the way around once, and then come back around to pi over 4. And that would correspond with an angle of pi over 4 plus 2 pi. And so if you get a common denominator, you'll find that's 9 pi over 8. And I could keep on doing that with adding on 2 pi and doing more revolutions around the unit circle. And to find as many representations of pi over 4 as I want. I could also do the reverse of going around the opposite way and ending at pi over 4. That would be pi over 4 minus 2 pi. Oh, that dark blue isn't a good color to use on the background. Which is negative 7 pi over 8. So you can go in either direction to find different representations for pi over 4. And that can cause a real headache in certain contexts with complex numbers. But that's just the nature of the beast. But that's why I had to do the subtracting off 2 pi thing. I had my first exercise from uni that took me like many hours, and I wasn't super sure how to do it. It was crazy, but I got it done. Ooh, nice syntax. That hopefully felt good by the end of it. Next illustration of that would be to calculate I to the I. Oh, I think I've done that before. We could do it again though. Complex exercise, she in French. Oh, nice. Thanks for passing that along. Underscore. I feel like all I need to understand is how to propose arguments. I think I can get that by reading Carathéodory's proof. Maybe construct a Lebesgue measure from just an algebra. If I understand that, I'll feel more comfortable understanding proofs. Fair enough. So like e to the minus pi, I to the I. It's gonna be a real number, I think. So if we want to calculate I to the I, we would look at the base and notice that it's like e to the I pi over 2, then to the power of I, and then a power to a power multiplies. So I times I is e to the minus pi over 2. So yeah, an imaginary number to the power of an imaginary number is a real number. Go figure. Oh god, dual numbers. I never done anything with dual numbers. And Alman, I'll wait to hear you type something in chat before I move on to the next question. Let me know if you have anything about what I've already said. But just in case you went AFK or something, I won't move on until I see you say something. So that's right. Epsilon cubed is 0, squared is 0 and not 0. You got it? Okay. Then I'll move on. I'm just curious if I can quickly figure this out first. I assume they don't have... It might not be easy to calculate because there might not be a nice property with powers. Ooh, maybe the matrix is what you want though. Can you do a matrix to a matrix though? That might be difficult. No, dual vector spaces or finite dimensions, I don't think I have. Yeah, so I'm not sure of how to figure that out, JC, but probably something you can do there. Epsilon to the epsilon equals exp epsilon ln epsilon. Oh, you can figure out what ln of epsilon is? Oh, did they have an e in there? I didn't even see. Oh yeah, look at that. Vector space made of functionals from V to F, where F is the ground field. Ooh, okay. I have done something with functionals with the general relativity stuff, but I haven't done anything that's really mathy with them, I guess. Oh, it's defined by, okay, it's just like the power series. I think syntax error probably has the right setup. Or it's the right first step. I don't know though. You could, I guess, then use a power series as well from syntax's first step. But I want to go back to Almond's questions and get through these. So Almond said we can skip 2 and go right to 3. Which of these vectors below can be expressed as a linear combination of the vectors 2, - 2, 1, and 1, 1, 2? Okay, and I saw you ask if this is like the 3x3 determinant thing. You could use determinants here. It would be very tedious though, because this would be the determinant thing I showed you was cross products. You could, and that's like a special case of determinants. Determinants in general could be helpful here, but they're going to be, they take way too much time to actually calculate. First off, we should talk about what a linear combination even is. Cylindra, thank you for the follow. It's a funny name. I feel like I have the wrong steps. You got, yeah, that does look a little funky. I wasn't following exactly what you did with all of that, but oh, you did the 2/2 thing. I don't know if you want to do that. Yeah, I think you should use a power series, but I don't know how it's good how it's going to look. After we do these next 2 questions, we can explore that though. When we get a Roblox trig roleplay stream? Probably never. I don't know if that's what that means. Okay, so first off, let's talk about what a linear combination is. You know, I kind of... One second. Oh no, I'm dumb. Ah. I need 2 seconds. I lied. 1 second is not enough. Ah, I need 3 seconds. Okay. I just wanted to get this as a separate question so we can have it up there. So, a linear combination of two vectors is the sum of any multiples of those two vectors. And so how that looks in math is an example of a linear combination could be, let's just say 2 times u minus 3 times v. And we could actually go and calculate that if we cared to. 2 minus 2, 1, minus 3, 1, 1, 2. This 2 gets distributed to each of the elements in there. Same with the 3. So we get 4 minus 4, 2, minus 3, 3, 2. And now we do element-wise subtraction. So 4 minus 3, minus 4 minus 3, 2 minus 2. 1 minus 7, 0. So that's an example. You could say that 1 minus 7, 0 is an example of a linear combination of u and v. This is a really important topic in linear algebra. And we could have chosen any real numbers we want here and here. So positive or negative fractions or rationals, all of those. And I would think that the best strategy here is guessing and checking if you need to solve this quickly. You can like reverse the vectors and just go through each one. Yeah. That's a strategy I would say here. So like looking at answer A, we can figure that out, yes or no, pretty freaking quickly. Because look at just the first element. We have a 2 here, a 1 here, and a 3 there. So the only way we can possibly make that 3 is just doing u plus v. So let's do that and see if the other numbers check out. So I'll write this one out in a bit more detail than I normally would, just to show the process. So u plus v, we get the 3. We get minus 2 plus 1 is minus 1. And already, we have a minus 1 here, a minus 5 there. A is out. Oh, wait. 2u minus v is in shambles. No, that doesn't get us a 3. Oh, there are more ways to get 3 there, aren't there? If we use only one of the vectors. So oh, you know what? This is a little bit. I am making a little bit too simple, I think, aren't I? I was thinking I could also have done 0u plus 3v because there's a 1 there, and that would get us a 3. 3, 3, 6. And I'm also wondering, I wonder if there's infinitely many ways to get a 3 with using both U and V. Are there? You know what? There actually are. Is this a good strategy? Yes, Cylindra, I know it's possible. I just wanted to avoid doing that because it's such a pain. I'm definitely... Wait. Hmm. Oh, are you allowed to use a graphing calculator? Yeah, there's definitely time pressure. Like I think the pace is like a minute per question or something like that. Maybe like a minute and a half. So we got to be able to do this quickly. Um, if your graphing calculator can do determinants, I do think that is the proper way of doing this. Try option D, which I think is the answer because that has a 0. You saw I never even heard of that. Tessa math applications. Okay, well um you minus 2v. Okay, so since it sounds like you can use the determinants in a calculator, Semitech. Oh, I haven't heard of that either. It's possible to prove in math. Also, welcome in Cylindra. I didn't say that already. You can prove that oh wait, it's columns, right? Well, rows and columns would be the same. Yeah. Oh, okay. If the determinant of a matrix is not 0, then it's columns, and I think rows are linearly independent. And what that means, Miss Venture and Astro, thanks for the lurk. Welcome in. I should have given you the flip side of this, which is matrix is 0, then its columns and rows are linearly dependent. So I should have given you this version, which is if things are linearly dependent, it means that it's possible to write the 3 things. Let me just show you an example. So I'm going to make a matrix out of the vectors that were given. So 2 minus 2, 1 is u. It doesn't matter if you do it as rows or columns. It should be the same. 1, 1, 2. And then this will be whatever the options are. So, spoiler alert, we've been told the answer is D. So if we choose D here, do U cross V, then dot with choice to check if 0. That's still way too many. No. No, that's way too many calculations. That would work though. Hey Phobos. Hope you're well. The order does not matter, no. And so actually we're gonna take the determinant of this. So I'm gonna use the other notation, which is these absolute value bars. If you take this determinant of a 3x3 matrix, we will find, since it's the answer, that we get 0. An answer of 0 means it's possible to write one of these vectors as a linear combination of the other ones. And that's what the question is about. So it will be good to actually for us to like verify this, but if you get 0, it means that it is possible to you got it. Okay, good. And so if you get any number that's not 0, it means they're all independent, which means you can't write that linear combination. This is a real crash course because there's so much more that like we could talk about with like the linear algebra of this that we're kind of missing out on. That's cool. But that's like the bottom line of what you need for this. Hey, color cone incandescent. I'll read that. Actually, I can read it now because we're between questions. It's so satisfying to construct a perfect matrix from an endomorphism v to v, where you assign each coordinate an arbitrary eigenvector. From the construction, you can get rank nullity theorem, minimal polys, and direct sums. If the matrix diagonalizable, also you can do a change of basis from an endofunctor. That sounds like a sci-fi word. K-vect to k-vect. The idea is simple and beautiful, which is just literally adding an independent vector n times if you want n by n matrix. Eigenvector with respect to the eigenvalue. Huh. I don't know what a good amount of the words you said are, but I can understand. I can half understand what's happening. K-vect to k-vect. On the next one, you're just wondering what it is. You just got to multiply them and do AD minus CB. Let's see. Mamma mia, we've got ABBA in this question. Find the determinant. Ooh. I'm pretty sure we can simplify the work here. I just want to make sure I'm not gonna I just want to verify one property of determinants. For the determinant of a product, I think it's the product of the determinants. I just want to verify that though. Yes. Okay. This question is a lot. It's still a little bit annoying, but hey, Armand. I'm doing good. How about you? So asking us to find the determinant of A, B, A transpose. And so if you wanted to, you could go through and do this matrix multiplication here and then get the determinant. We can do this faster. And I mean, if you're using a calculator, this could be pretty fast. If we're doing it by hand, though, we can speed up the process a lot using properties of determinants. So one property of determinants is that the determinant of two matrices multiplied is the product of the determinants. So you can basically split it up. So here that's going to look like determinant of A, determinant of B, determinant of A transpose. And then there's another property, which is the determinant of A transpose is just the determinant of A. It's the same thing. So really we only have two determinants to calculate here. Determinant of A and determinant of B. And 2x2 determinants are pretty like quick. So I would just do that. I remember you, Armand. Sort of. I think it's been a while. Oh, what is transpose? That's a good question. The transpose of a determinant is it's not quite mirroring it. So this is the matrix A. If you take the transpose of this, the main diagonal stays the same, but all of the off diagonals swap. So the 1, the 4 stay still, the 2 and the -3 swap. That's what the transpose does. It makes the columns into the rows and the rows into the columns. So it might be even better to see with a 3x3 how things move. So you could see it as like this 147 column. The first column becomes the first row, 147. The second column becomes the second row, 256. Third column becomes the third row. Or you could see it as the 159 stays the same, and then the 2 and the 4 swapped, the 3 and the 7 swapped, and then the 8 and the 6 swapped. They're both like equivalent. That's another like useful thing in linear algebra. But that's pretty much all it's doing there. Infinity 2 derived endofunctor. Welcome to modern category theory. Is determinant homomorphism? I wouldn't know. If you want Armand, I think we're pretty close to getting it anyway. Aaron Flynn, thanks for the follow. I'm not a college professor. I'm a graduate student. It's like turning 90 degrees, flipping it over the y-axis. 90 degrees. Oh, yeah, I think I can see that. 90 degrees. Yeah. I think it's kind of like that. That's a funny way of imagining it. I'm not sure if it's exactly that, but it's kind of like that. When you catch up with Destin's chat, I recently learned this. It's a better way to approach the learning algebra, not knowing what's going on. The experience is similar when you learn an entire semester of abstract algebra, and you learn group action G times G yields G, produces a class equation, which pretty much destroys every single theorem in the entire year, where star equals X. C is the map GL K. K is the field, yes, the group morphism. My name is Don Armand. GLNK initial final object. You can send me a question. You put them there in chat or in the Discord. Okay, so how often? I don't really have a schedule. I just do it when I feel like it. If you have questions and I'm not around though, there's many other people who stream math besides me. There's a whole list of them there. Okay, so do you know what to do for the rest of the question then, Alman? Can you explain like base questions? Like, I'm thinking of like exponents and bases, but I don't know. You probably mean something else by that. If you want to post an example, go ahead and do that. Grind, don't stop. Good luck, Destin. Just in the meantime, I'm gonna get the answer to this question. Just 'Cause I want to see it. Ten. Oh, okay, so yeah, the answer will be 1,000, right? Okay. I've studied statistics, yes. SPSS, I don't know anything about. Find the remainder when base 8. Oh, no. Numeral 173 is divided by base 8, numeral 12. Oh. I hate those too. Skirtle. Happy birthday. Everyone say happy birthday to Skirtle. Hope you're doing well. Oh yeah. Happy Roblox birthday. Um, they were great. Ooh, nice. You're getting 300? It should be 1,000. 300 isn't an option. Do some implicit differentiation. I do know that. If you want to post a specific example, I can work on that, Aaron. So I'm not that experienced with doing arithmetic in other bases. If you want to convert between bases, though, let's see if we can muddle our way around this. So the way that it is okay. So let's start by saying how bases work with the normal base 10 numbers that we're used to. If I have the number 1,732, I don't know that one is coming to mind. You have a ones place, 10 to the 0, a tens place, 10 to the 1, a hundreds place, 10 squared, and a thousands place, 10 cubed. And so we could write the same number, 1,732, as 1 times 10 cubed plus 7 times 10 squared plus 3 times 10 to the 1 plus 2 times 10 to the 0. There's a question on middle school regions that was like converting fractional bases. Oh my god. No, this isn't the last question. Okay, I see your question there, Aaron. You'll be up next once we've gone through this. So if we have 173, in base 8, I think they do like a little 8 subscript like that to denote base 8, if I remember right. What we have is a ones place, 8 to the 0, an eights place, 8 to the 1, and I guess a 64th place with 8 squared. But we can do the exact same expansion with 1 times 8 squared plus 7 times 8 to the 1 plus 3 times 8 to the 0. And if we actually calculate this, we'll be back in base 10 land. So it would be 64 plus 56 plus 3. 123? So, and I can even write in base 10. Usually we omit that. So that's how you would convert a number from base 8 back into base 10. The process of going into base 8, though, is even more of a pain, if you can believe it, because you basically have to you take your base 10 number and you subtract off powers of 8. So, and this is where you have to like, you start with the highest power of 8 that is less than the given number. So the highest power of 8 that we can fit in here is 64, 8 squared. You subtract that off, and you would get 59. Am I stupid? Oh wait, this is a little bit more subtle than I was thinking. I'm doing the binary thing, but that actually, I'm just reasoning that that's limited now. This I was taught to convert binary or numbers into binary, but this actually, I think that only works for binary. Oh, that's such a pain. The way that you have to do division and then subtraction. Well, no, but like the next thing I need to subtract out is 56, but that's like, that's 7 times 8. And it's just dumb. Wait, what? Oh. You're subtracting the highest power for binary? Yeah, yeah, the issue is that we might have multiples of the number, which we would need to account for. Yeah, so like we're technically doing division here, but the numbers are small enough that we don't have to actually show it. Okay, so basically, we start with the highest power of 8 that can possibly fit inside here, which is 64, because 8 cubed is going to be something really big that will be more than 123. But you also need to ask yourself how many multiples of that 64 you can possibly fit into 123. In this case, it's only one, because 64 times 2 is just a little bit too big. So we only get one. Like, that's why we only get 1 times 8 squared. But then in the next thing, we can fit in 7 times 8. You get it? Okay, good, because I'm explaining it terribly. Quotient is 14, the remainder is 3. Maybe. I haven't gone that far. Just the division? Yeah, the division I'm not... I don't think I've done division in other bases yet. That's why I was procrastinating on that part. Can we just directly... I feel like we should be able to directly do this division without converting it. Well, if we just treat this like it's normal division, do we run into any minefields? So 12 goes into 17 once. Yeah, okay, this is where it's going to get tricky. Because this is 53 base 8. The remainder is 3, but you don't know the quotient. Okay, that's good to know. So let's think about 12 in base 8 times 2 in base 8. That is 1 times 8 to the 1 plus 2 times 8 to the 0 times 2. So we get 2 times 8 to the 1 plus 4 times 8 to the 0. So we still get the 24 in base 8 that we would think that we get. I think with small numbers, the multiplication isn't going to be that much different. So we can do a 3 here. The only issue is that once we have to carry an 8 is where things will get weird. We're just so like if this was a 4 instead, we would get an 8 here, and then we get something a little bit trickier. But so far, we're okay on that. Actually, no, I think I could even figure that out now that I'm thinking about it. But we get a little bit. Oh wait, no, we do get a 4. Oh, okay, yeah. Oh, okay. I think I understand what happens here. From the base 10 isn't 123 over 10. Yes. You could do that and then convert it back into base 8 if you cared to. Oh, and I guess the remainder 3 would be the same. So you definitely could do that. Yeah, double, triple. I think you're right. Also, hey, I hope you're doing well. So yeah, converting them both to base 10 and doing that is definitely possible and valid. Out of curiosity, I wanted to do it directly in base 8. Am I planning for my masters? I'm doing my masters. You forgot to do this? I'm just figuring out how to do it right now, right? So yeah, if we want to do 12 times 4 in base 8, what we would do is we do multiplication like usual. We just have a different rules for when we carry the 1. So 4 times 2 is 8. But 8 is like our 10 because we're base 8. So we put a 0 here and we carry a 1 here. And then 4 times 1 is 4 plus 1 is 5. And so like as a different back in base 10 land, if we had like 15 times 3, we'd say that 3 times 5 is 15, but that's more than 10. So we just put a 0 there and carry the extra. Wait. Oops, I did that backwards. We put a 5 there, and we carried the 1 above here. I was like, that's not right. So it's the same procedure for multiplication. You just have to, instead of looking out for 10s, you have to look out for 8s. So this will be a 50, and then we subtract that off, so we get remainder 3. So we do get the remainder of 3. So if you're taking if you're doing the actual competition, you have to do this quickly. The slow but sure way is to convert to base 10, do the division, and you have to make sure that the remainder, you convert that to base 8 back at the end. But 3 is the same in base 8, so that's not important here. Doing too much? Just convert to base 10? That if you can do that quickly, I guess go ahead. I think if you're comfortable with it, this is just a lot faster. No, I was doing a base 10 example just to show like the similarities. Uh, would it be 47? I think so. I don't have an official like Instagram account, Armon. Um, but yeah, so like a helpful thing to remember is that in base 8, the digits are only like 0 through 7. You'll never have a 9 when you're working in base 8. Or you'll never have an actual 8 in base 8 either. You have like less digits. But if you think that the conversion thing works better for you, then just go with that, I guess. IG.com/Don Factorial. Oh shoot, I've been making Aaron wait for probably a little bit too long here. Sorry, Aaron. Almond, I'm happy to answer questions about that if you have more, but I just remember that I've been waiting a bit too long to get to this question. So Aaron, sorry, for the wait, but if we want to take the usually the question is like find dy by dx for this implicitly defined function here. So what we do, let me write down the original equation again, is we're going to take the derivative with respect to x on each side. So d by dx. On the left side, we each get their own derivatives, so we get 3x squared, but then we have to take the derivative of this y cubed. And so how it works is we kind of pretend that y is an x. So we apply the power rule, so we get 3y squared. But anytime you take the derivative of a y, you have to multiply by dy by dx. That's because of the chain rule. Yeah. I can explain that more, but no, Armand, if you want to go, then go. And then on the right side here, we have x times y. So we're going to treat this as a product rule. So we'll take the derivative of the x first, which will just be 1. So we get 8 times y. And then we'll take the derivative of the y, which goes to 1, but then multiply it in the dy by dx. Arithmetic is the same in different bases. You have 8's place, 8 squared. Yes, it's cylinder. It's just like actually doing it is easy for me to get tripped up on, but yeah, it should be the same. And so now the only task here is to isolate dy by dx. So get dy by dx is on one side, everything else on the other side. So I'll subtract this over, subtract that over. 3y squared dy by dx minus 8x dy by dx equals 8y minus 3x squared. Factor out the dy by dx. And now just divide this bit over, and that's our answer. So there you go. If you wanted, you could. So sometimes if like if it's like a multiple choice test or the homework software you're doing it online and it's finicky, you might want to multiply it by -1 over -1. So the x's go first, which is usually how people write stuff, but it's all the same, but there's another way of showing the same fraction like that. But in my mind, these are both the right answer here. minus fx over fy? I'm not sure I know what that one is. When we use partial differentiation. Oh, I mean, that's just kind of a different thing. Oh, does mean like, oh, you know, I never thought about that. Yeah, it would be the same, right? I think I never realized that. dy by dx, how does that expression actually look? It's going to be like, I don't know if that's bad. I'm sure there's like plus something else that I'm missing. Sounds like we agree, Armand. Oh, yeah, you're probably right, Aaron. It's possible to plug in equations like 3x minus y squared equals 11 through parametric equations. You can make parametric equations out of any single equation if you want. The kind of cheap way of doing it is to give 3x minus 2y squared equals 11. It kind of feels like cheating, but like the easy way of doing it is to say x equals t and then y equals whatever this is, but with t instead of x. Oh, well, here it's a little bit more difficult because of the squared. You need like a plus or minus. But instead of an x, you just have a t, so. But yeah, that's kind of like the general way of finding parametric equations. Yes, it was product rule because y is just a function of x. You know, it's theoretically equal to like some like combination of x's, like x cubed, sine x, whatever. And so we're kind of appealing to like this form of y when we apply the product rule here. But we don't know what y actually is. And so we just say the derivative of y, whatever it happens to be. But I think since y is just something that made up of x's, we're allowed to take the derivative of it with respect to x, but we just don't know exactly what it is. Why? I hit undo too many times. Usually the theorem that tells you can do it is the implicit function theorem. It requires you to have certain condition on the derivative. Oh, really? Hey, Codify. Why is it called implicit? Because y in this case is an implicitly defined function. What does it imply? It implies many things. Oh, nice. Did you get your OBS stuff set up, Codify? Makes it implicit. Well, you would write y explicitly. Like if y is explicitly defined, then there's a single y over here that's isolated equal to something involving x's. But when you have y's like mixed in and you can't quite isolate y, like in this situation here, then we call that implicit. So curves given by f of x y equals 0, where f maps R2 to R. Oh, that's probably how the chain rule thing works then. Okay. I think. Is what you're talking about, color cone? I'm from America, Aaron. From California. Okay, that's how you do the partial differentiation thing. Okay. My multivariable chain rule is really weak. It's like it's the most basic part of multivariable calculus that I feel weak on. Doing the chain rule. So the thing we want to find is the ordinary derivative of f with respect to x. Is that how we're going to get the equation here? So that df dx plus df dy dx, something like that. Chain was the opposite of composition of functions? Yeah, right. Differentiated with x then to y and minus fx over fy. Okay. Yeah, that's always such a weird thing where like f of x comma y, it's essentially a function of one variable, but you can also think of it as a function of two variables. The thing that trips me up the most that we've been talking about in my complex analysis class is a function of z and z star. This one is even worse because z star is just like it's not like an independent variable, I guess. I have a really hard time wrapping my head around this being a function of two variables. But in certain situations, it's important to think of it like that. Aaron, that's a little bit off from what I got. You're missing a y. Well, also we're off by. I think we're off by a sign, and you're missing a y and an x. Period of a function. Ooh. That's gonna be a tough one. Not troll question. Can you compute the derivative of det r to the n by n to r at the identity matrix? No, I don't think so. Hey, why you forgot to type it? Okay. It's its own since it's a dual. It's like it's the same because you use z to derive the dual z star. But like the derivative of a determinant of a function evaluated at a point? Is it just 0? Because you get the identity matrix? I don't know. Um, so, Alvin, do you know what the period of a function is in general? You also have verbal math questions you must solve within 5 seconds, which is the same that is wild. Oh my god. That's high pressure. Oh, thank you, Atom Fighter. It's a zone since it's dual. Yeah, no, it's just a weird thing. Oh, maybe I have seen that before, Raven. That looks familiar when you write it out like that. You don't know what a period is? Okay, okay. So a period function, or the period of a function applies, well, to periodic functions. A function is periodic if it repeats itself. So the trig functions are examples of periodic functions. So this is just a regular old sine wave, and I'm gonna do 2 vertical bars. This is one period of sine from 0 to 2 pi. Because you could take this one little bit here and kind of copy and paste it like all the way to the left and right. It's the exact same thing. And so the period of sine is 2 pi. It's the length of just one of these repetitions, I guess. You can have a different period, which you can show an example of. Cube root is not periodic. There's no like repetition here. Yeah, like I guess the point of periodic function is if you know how it looks in one period, you know how it looks for every single value of x. Like this peak here corresponds exactly with this peak here in the next one, and this peak here, and this one there, and also off to the left. So sine is a period of 2 pi. We can show a different example. Tangent. Tangent is a period of just pi. I need new bars. So, tangent, one period of tangent is defined from minus pi over 2 to pi over 2. So the length of that interval is just pi. So tangent is periodic in pi. Sine is periodic in 2 pi. Cosine is also periodic in 2 pi. Here's every y point you touch is move along the x-axis. When you touch the y point again. That's a good explanation for tangent, Atom Fighter. I don't know if I would agree with that for like sine though. Because for sine, you hit the same y point twice in this one bit here. Typically just the trig functions, can't think of other periodic functions, so you can manipulate trig functions to have different periods. That's true. Yeah, we should talk about that, Cylindra. It is pretty common to manually, like, you can make any function you want periodic. Like, you can take a piece of a parabola and make it periodic too. That has some importance with, like, audio and stuff like that. But the ones you normally encounter in a math class are just trig functions. And yeah, Dr. L put, like, the math way of talking about a periodic function. Graph the equation, I showed the answer is 2 pi. Yes, and so this one, the answer is, the best thing to do is just to graph it. I'm sure there's a way mathematically you can figure out what's going on there. But if you have a graphing calculator, I will just do that. Because when there's two trig functions being added together, it gets a lot trickier. Because you get these funky looking things. Is this 0 to 2 pi? Oh, maybe it is. Oh yeah. Wait, it doesn't go earlier though, does it? No, it doesn't. Okay, yeah, it looks like it's a period of 2 pi. Local minima, that's where the function has a valley, basically. So this right here is a local minimum. This is a local minimum. This is a local minimum. Just anytime it bottoms out and comes up. Normally, you need calculus to find where they are. Depending on the function, though, you can use known properties of that function to find them too. You can also use that trick for solving the heat equation on a rectangular domain. I don't remember what trick we were talking about. Oh, like the periodic thing? Because they're solved by whatchamacallits? Fourier? Yeah. That's right. Okay, yeah. That makes sense. Find the mistake. Integral of e to the x equals... Oh, wait, e to the x sinh x dx. Oh god. Integral e to the x sinh x dx. Via integration by parts. Hey, find the mistake. This is definitely way easier to use the exponential definition of sinh, by the way. But this works too. Or it should work. Sinh is not periodic. This is a different question that Dr. L put. I'm not sure if this is going to be a meme or not. Knowing Dr. L. Or you just don't like that sinh isn't periodic? Maybe, Raven? There's a good reason. It doesn't have any imaginary numbers. If it did, things might be different. Oops. Oh. I see what Dr. L is saying here. You can subtract off the integral from each side of the equation. What is the mistake? me not squish my work in so much. I guess you could say they're equal to a constant. Like, do we need to worry about the constant of integration? There might be an over 2 in there, Lucas. It might be a plus as well. I always forget the exact definition. If your neighbors are all higher than your a local minimum. Oh yeah. Can you explain this 5-second question? I think there's a trick to it. How many terms in the expansion of the quantity 15x minus 8y to the power of 15? Oh. I want to say 16. I don't know why my mind goes there, though. The trick is the binomial theorem. If you have x plus y to the n, which we basically have that, it just looks slightly different. N is 15. You end up with a sum. Oh, it is just 15. No, it is 16. You end up with a sum from 0 to 15. And so that's 16 numbers, right? Because we're starting from 0. So the trick is knowing that this thing exists here. It's just a summation from 0 to n. That's why my mind instantly went to 16, I guess. Also, this part v should be minus cosine. For caution cinch, I don't think there's any sign flipping, I want to say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Proof for gamma function, the factorial looked pretty fun. Yeah, the gamma function is cool. If you actually want to solve the integral, you'd sub for sinh x equals, yeah. Yeah, integrated by parts should be correct too. I don't know why it's making a mistake here. Does integration by parts actually have a restriction? Without looking, I'm assuming it's the same trick we integrate e to the x sine of x, do it in terms of itself. Yeah, like that's the thing that's being that Dr. L is pointing out here. If I stopped working out the steps, but if I pick it up from here, you get e to the x cos x minus e to the x sinh x plus e to the x sinh x dx. And then the left-hand side is just that. And so Dr. L is saying that, like, why can't we cancel out the integrals here? Like, just subtract them from each side of the equation. And get that cosh equals sinh. It's obviously not true. I think there might be one point where it's true, but I shouldn't say the word obviously. Yep, I believe that's true. Lucas? So this is the thing that Dr. L is like telling us to find the mistake in. And I don't know what it is. Basically always the exponent plus one. Oh yeah, Almond. That's the trick there. It's weird. It just comes from the product rule. It should always be valid to integrate by parts, right? Huh. About introducing a new number for some time now, it will be cool. Oh yeah, I mean, I remember talking to you about like division by infinity or by zero, rather, being like an imaginary number. Yeah, I guess it is that we need the constant of integration. But it sounds like a Minecraft villager. Huh. Um, which maybe saves it. It's not false, right? That's the only thing I can really like think of though. I bet there's a Stack Exchange thread about this. It might be wrong to claim that two integrals subtracted are zero though. That's I'm not quite sure how I feel about this claim. But couldn't they be equal to a constant instead of zero? Want a hint? Yeah, sure. So we know E was formed doing that again, but for between 1 and E instead of between 1 and infinity. I'm trying to think of how E was formed with intervals like that. I don't remember what that is though. Is that an identity? Oh, I don't care personally. I'm terrible with hyperbolic trig identities. Uh, I mean, we should be able to see this. Uh, okay, so if Kosh is even, so it must look like it has to have a plus, right? And sinh is the one that has the minus. And there's some hyperbolic trig, like double angle or something, or half angle, whatever. That's not related. There is no constant? Huh. Oh, right here? I have a sign mistake? Oh. That's a plus. There we go. Thank you. That should work out to something better now. Antiderivatives aren't unique. They're only unique up to an additive constant. Oh, did I make a double mistake? I did. So wait, what? And a sign mistake. Ah! Oh, I had it right the first time. Oh my god. Oh, wait. Oh, duh. Yeah, what I was trying to show is that 1 equals that. Okay. I lost track of what I was trying to do. Antiderivatives aren't unique. They're only unique up to an additive constant. So yes. So it was still the constant of integration that was like helping this. It's what makes this still be correct. But integration of parts isn't helpful. That's weird. So I guess the moral story here, integration of parts does not work for this integral, but you do get something that looks weird that is still correct. Oh, hey, look, I just proved that 0 equals 1. Check. Yeah, okay. Math is fucked. Okay. And then we could find that the constant is 1. Checkmate math. 0 equals 1. Where's your precious consistency now? That's weird. I like if someone just gave me that problem and I didn't think to use the exponential version of sinh, I would be so confused once I got to the cancellation of the integrals part. Doubly periodic functions? I don't know if my book covers that. I'm curious to find out now. I need to bring up the book. 1 second. Doubly periodic functions. They have like a period inside of a period? I don't know if I would find it in here, to be honest. Maybe I should just control F. Doubly. Doubly infinite. It's not the right thing. Oh, hey. In chapter 3, I skipped over it, apparently. Or maybe a starred section. Oh. What? Weierstrass P function. Never heard of it. I'm having a hard time visualizing an example of this. It's probably a Googler. Functino? It's a two-dimensional extension. So it might be hard to visualize this. Yeah, Ranga, that's the real answer to doing the integral, but you do get something weird if you do integration by parts. Okay. Pairs of reals, two reals, and then assume the periods are 1 and I? What? I need a picture. Is it just periodic in two different directions? Is that the point? Linearly independent vectors. Maybe that it's just okay, that makes more sense. There's not a single picture in this. On a lattice. You hate how integration by parts is taught? Do you have a better way of teaching it? Oh, that's a messed up P. What the hell? Okay, yeah. Okay. That's such a weird idea. Being periodic in multiple dimensions. So like omega 1 and omega 2, like a convenient choice would be one is strictly real, one is strictly imaginary, or purely real imaginary. Necessarily non-real ratio. I think that would have that would enforce that condition, right? That's another way of saying that. The linear independence bit. Yeah. Product rule reorganize things. Yeah, that's how it was shown. I remember not understanding integration by parts when I was initially taught it in that way. Oh, nice. Yeah, it makes a lot more sense when I think about like sound waves like that. To make sure they're not multiples of each other. Okay. Got a new number idea? What is it, Lucas? Periodic function, one variable can be thought of as a function living on the circle. Doubly periodic functions are functions live on the torus. The torus a donut? I always forget. It is, okay. Huh. Getting hypnotized? Oh yeah, by the like optical illusion thing. Homer Simpson's favorite surface. X plus 1 over x to the x equals x. We can definitely get a numerical solution for that. This number feels, it has, it looks like the definition of E on the left side, I guess, but I feel like that the golden ratio is going to sneak in this somehow. 2.29 something. We can call Lucas's number. Taurus sounds like something from Interstellar. Oh, there is that robot. What was his name? They had the robot companion whose name started with a T, I think. Taurus? I think it was like TARDIS. Interstellar robot name. TARS? Oh. Okay. There's an Interstellar wiki? Oh, get a life. It's not that good of a movie. Oh my god. Why? There's a game app? Huh. It is? No, it's okay. Game app. Maybe there's also a game app. I don't know. Simpsons tell me e to the pi I is -1. It's in the background Simpsons episode. Oh, really? I haven't seen that one, Renga. That's cool. The ODE you have in your book is the equation of an elliptic curve in the projective plane. Oh, really? That one? Or probably no. This is the ODE. No, that's a general ODE. Below. Oh, this. There's a brain rot wiki. Oh my god. They're giving me an Expanse video game. I have not heard of that. You have a calculator emote? Nice. Plug the e to the pi into my calculator in 7th grade when it's very confused. Yeah, I think I've done a similar thing. Oh yeah. The golden ratio is just a number that crops up in math. It's another irrational number. And I was thinking of the golden ratio because it's the roots of the parabola. If you do the quadratic formula, I think with x squared minus x minus 1, you get the golden ratio. Is that right? Yeah, it is that. And so people sometimes mess around with how this quadratic function looks and they make it look something a little bit like the stuff that you were rating, but I don't think it's actually connected. I just kind of had like something flash through my brain of some golden ratio problem from a long time ago. Oh wait, you know what? No, yeah, I can see it now, because if you can say x squared equals x plus 1 and divide x by each side. So this is that's why I thought of the golden ratio, because that looks almost the same as that, but it is fundamentally different because of the exponent. The real plane circle can be parameterized by cosine and sine. The complex analysis P and P prime parameterize an elliptic curve. Ooh. Okay. So for like an ellipse, it would be something times sine and something different times cosine, I guess. Take any positive number, square root it, add 1, square root that, add 1. Oh, neat. Yeah, I learned about like the golden rectangle and stuff like that. I don't think I've heard of that procedure though. It probably ends up being the same thing. There's like a smudge on my glasses. You made up out of boredom? Oh, nice. Okay, so I think the questions have slowed down a bit. I might go back to reading my paper. But if someone does have a question, let me know. I have too many tabs open. Okay, so what I was doing at the start of the stream, and what's in my stream title, is for homework I need to read through this paper and answer a couple of questions about it. How come my students can't do y equals mx plus b? Because you're not teaching it well enough, or you haven't taught it yet. Maybe. I don't know. I haven't been an actual like teacher, but at least as like a tutor, I always thought if a student didn't understand something, it's my fault and not their fault. Okay, see, now that's a little bit that is a little bit different. If they're in a college class, they either are really not trying or they've been failed by many of their teachers. That yeah. You're right. Okay, so when you asked the question, I assumed it was your responsibility to teach them that, but it isn't your responsibility to teach them that. So that does change the answer. It shouldn't have to be yours. Yeah. I don't know. That is a pretty common experience where students just like skate by trying to learn as little math as possible, and then when they get stuck in a calculus class, they come to regret it. I dealt with plenty of those students as a tutor, but to be honest, I never minded it because, I mean, I was just a tutor, so it's not like it's on me if I don't have like a classroom full of students that don't understand like a prerequisite idea. Raven, you probably just taught it differently then, or like taught it with a different form. Y equals mx plus b is like, oh no, I just did something terrible. Oh, okay, it's okay. It's the, slope intercept form of a line. I'm sure you've seen something at like similar to this in some way. Oh, you were? Okay. Oh, I get the joke now. Okay. Sorry. I was like, I know you know like math and physics, but I couldn't remember like what country you're from, and so they do generally teach things differently in other countries. Like, oh, maybe they just do like point slope form or like some other form of a line, or the dreaded standard form. There's no teacher, there's only a student. Student's job is to learn. Do I agree with that? I feel like if a teacher has that attitude, most of them are just going to not try to teach. But if you mean having that attitude as a student, I can see that. But I don't know, I'm a little bit puzzled by what I'm supposed to take away from that. Shouldn't require such an advanced knowledge from students, like y equals mx plus b. Yeah, you know, who even needs y equals mx plus b anyway? Problems in box with a square base and top. I draw a picture, label the bottom x by x, the height h. Oh, I mean, that's a pretty... That's a pretty early on thing, like the volume of a shape. Man, yeah, that'll be really discouraging if you're a teacher and your students can't do that. Like, I have a hard time giving advice on that because, like, I don't have any formal, I've never been an actual teacher with a classroom full of students. I've only ever, like, tutored. I don't know. Yeah, that'd be, oh man. That will be super frustrating, Renga. I guess in my mind, you would show them the right way to do it, and they need to realize, oh shit, I better get my shit together and study this stuff on my own time. That's my attitude, at least, where if I feel out of my depth in a class. I don't know. Students like to blame teachers for failure, but a teacher is just one more asset of many students. Okay, yeah. I can see that, Dr. L, for sure. I think the teacher should have some responsibility, but the students generally take too little responsibility for their own stuff. And like, as like a student looking at other my classmates, I've been like, thinking to myself, like, really? That's your attitude with this class? Like, I don't know. Let me read through JCYW. So weird question because I want to do part-time tutoring. It's strange because I would like to tutor people in college when I've just graduated high school. So it's equivalent to you in the UK, fair. You can't sell yourself because I don't have the formal qualifications. That's why I'm trying to join a tutoring team. I can make a response though, which is annoying. I'm not sure if they're just ghosting me. Your messages slash emails aren't getting through. Ooh, that's a challenge. Trying to tutor college students as a high school student. You do have a big disadvantage. If I was the person like looking at your application or potentially interviewing you, I would want a high school student to show me that they're qualified and that they're more mature than the average high school student. And I think those are equally important things. And you would need to figure out some way to prove both of those things, which for the math component, you have to have some really good test score, or you don't have homework qualifications. Yeah, please don't reveal information that would dox yourself. So if you can prove you know what you're doing, competent with chemistry. Okay. Yeah, that's even tougher, I think. Dr. L's suggestion might be good. Like, Wyzant or whatever tutoring website is popular in the UK, and just try to do it privately until you can get people to like, and just like literally ask students to be like references for you. He'll exam 1 scores prompt changes in study approaches. Yeah, Rangox, like there's only so much that you can do. If like the prerequisites exist for a reason. If the students don't have them, then that's not your fault. And progression would be to compute the derivative of determinant at the identity. Oh my gosh. I mean, there's a bit of downtime. You're saying that's a non-troll question? I should theoretically be able to figure that out? Let me pull that up. Feel iffy about joining these tutoring companies. I'd either start something on my own or join a private tutoring team. Yeah, it'll be hard to like starting something on your own is possible. Joining something else is a little bit, as like an employee, is more difficult. On Wyzant, you wouldn't work for Wyzant, as far as I know. You're like independent, and Wyzant is just like a platform to advertise, more like. But like trying to get hired by a company, I think would be challenging. Where's my Coke? Hey, mouse. Teach integral of e to the x and derivative of e to the x. There you go, Raven. That's huge. Don't be able to do it if I give you the trick. Okay. This is nice because they bring business to you. There's no investment of time except when you're working, getting paid. Yeah. Break problem to put smaller pieces to make it easier. Yeah, so like we start. Well, do we evaluate it first or do we do determinant first? I guess evaluate it first. Why is... Oh, okay. Oh, okay. So, yeah, the weird thing with remote tutoring is that like tutoring rates are going to vary a lot by location. You would really want to like look at other profiles and see what they're charging. But like for math, I would only charge like $20 to $30 an hour for tutoring. The rates go way higher though. I never really charged much personally though. Yeah, I imagine Wisant would take at least a small cut. Raven, you do pay tax for tutoring. Anytime there's self-employment stuff, people sometimes become dishonest with what they actually report, but you are supposed to pay taxes, yeah. List by hand all the permutations and SN calculate their sign. I assume we want this formula here. Why is debt differentiable in the first place? Oh yeah, I guess I don't really know the Levi's Civita symbol, but this is the one I'm more familiar with. Or even like this one. I'm gonna give him a traction anyway because my lack of qualification. I don't think it's much worth just start my own. Just join a team. Yeah, like I think you definitely need to do something where like it's independent and use websites to advertise yourself, and you have to start out not charging very much money until you can build credibility. That's continuous by inverse function theorem and well defined. Okay. Besides use algorithms for visibility, you need to learn how to game their algorithms to get high in the search results. That's when you can start jacking up your rate. Fair. I will tell you the determinant is a polynomial and matrix coefficient. Hence differentiable. Sure. We're taking the derivative with respect to, I assume, one of the entries in particular? Write the 2x2 case to convince yourself. So you can consider this a polynomial and say A11 or something? Or like any particular entry you want? X, Y, Z, W? Oh, like that. Okay, if they're all... Yeah, okay. Just to make my brain a little bit happier. So if the answer is 1, 1 is a good guess. Confident the thing I referred to that proved myself can give me great credibility. It's not formal, but should have enough knowledge equivalent to a degree holder. I mean, you can always just try. It's the worst that could happen. Should brand yourself a prodigy and charge a lot of money. There you go, Raven. That's the type of a marketing strategy that we need. Two by two. If you think of 2x2 matrices as elements in R4, the determinant is that. So a 2x2 matrix is like a 4-dimensional polynomial. Okay, yeah. Okay, so if you're evaluating this at the identity matrix, well, no, we're doing the derivative first. The evaluation at identity is the last. No? I don't know. I'm gonna give you some on the order of things here. Like, if I were to put parentheses in this sentence, we're doing this part first, it sounds like. And then, am I doing these parentheses? Or am I doing these parentheses? I probably these. Derivative first, right? Looking at this. Yeah, Raven, that I had the same question. Derivatives in multivariate are given by the Jacobian. Okay. In the oh my gosh, I remember the formula. Like I can half see the Jacobian. Jacobian. Kind of hard to prove. Determinant is continuous is useful to prove hyperbolic systems are dense. Okay. That is also an alternating bilinear form. So I think Wiki has Levi's Vita symbol or the Christoffel symbol. Oh, those things are related, right? I think. The answer is N, maybe. Jacobian mentioned. Okay. Not okay. We have 4 variables. But only a 2x2 matrix. Wait. Oh, it does make a bigger matrix. Maybe? No? I don't know. 4 columns and 1 row matrix. It does become a 4x4? So I was thinking that it seems like it needs to look like a 4x4. Grapple hooker? Hello? The Jacobian at a point will be a map from R4 to R. 4 columns, 1 row matrix. Okay. Now we're going to use a chain rule trick because computing the partial derivative in n by n will make us crazy. Yes. Morning, grapple hooker. Welcome in. Hope you're doing well. Consider determinant I plus TA. What do I do with you? Determinants, I don't think have nice properties with addition. it does look like an eigenvalue, right? Oh, is this gonna be a Kaylee Hamilton thing? Richard Nixon? I can see that. No? Oh. Something that has a less requirement? This problem is not a crook. Aru! Also, whenever I think of Nixon, I think of Nixon in Futurama. Specifically. What is the equation for the characteristic polynomial of A? Of A. A minus lambda I. Determinant. Well, this is like flipped though, right? Oh, I guess if we factor the lambda out, that's allowed with determinants, I think. I think we need the power of n. Stupid Twitch 0, thanks for the follow. Did I do that right? That? The minus sign is throwing me off? Oh, I guess... we can maybe fix that. So t equals minus 1 over lambda? Seems legit. Okay. How is this helpful? We're trying to compute a derivative of a determinant. Now we can look at determinant I plus TA minus determinant I all over T. the Jacobian matrix, apparently, Dr. L. Heloise? We want to find a somewhat reasonable expression for the numerator. Let's use the previous stuff we had. I'm sorry. I'm a little lost. I don't know. Famished. Eating 2 hot dogs and drinking a Mountain Dew? Hell yeah. That is the meal of champions right there. Anything on the hot dogs or just bun meat? You asked ChatGPT. It said the number has been discussed in some Reddit forums, although not widespread. It has also said that the number is at the very least interesting to look at mathematically and check out its characteristics. Yeah, like that. If you want to like find a helpful irrational number, I would think that you would need to be doing something else unrelated, and you happen to get that number. Am I close? I don't feel close. I'm completely lost with why we're doing this. Take the determinant? Oh, that's a derivative. I guess. Okay, no, I'm still lost. Never mind. I don't know what this really means. Like, is the function the identity matrix? I guess that doesn't, I don't know. Like, it's just a constant, it seems like. So shouldn't it be 0? I don't know. They could one for buy one, get one free, so you had to go and get it. You added veggies on both. One of them was a chicken hot dog. Ooh, that sounds good. How in the heli? Maybe connection with the golden ratio? Maybe. I don't know, it's kind of hard to like just find an irrational number. Normally they have to pop out of something else for it to be interesting. The end goal is to compute that derivative, so we can use the chain rule to obtain the derivative of debt. Equivalent to r to the n to the 2 to r. Compute the Jacobian of f of xy equals x squared plus y squared. One second. I'm working on it. What is it going to be when it's just like... It's been so long since I've had to do the Jacobian of anything. Like, it's just like a one-dimensional thing. Which is... Do we need to make it two-dimensional somehow? Oh, wait, well... Come to it. So is it it's not a square matrix, it's a 1x2? Okay, that's what I was getting tripped on. I thought it had to be a square. So it's 2x and 2y? Conjuring Last Rites is releasing digitally this week. I don't know what that is. Conjuring Last Rites. I don't think I've heard of it. So first column derivative with respect to x, second column derivative with respect to y. Because f maps R2 to R. Okay. That's a matrix that depends on our point xy. Sure, yeah. So it makes sense to compute the Jacobian of f at 1, 2. Yes. Yeah. It'd be, I guess, 1, 4. Uh, 2, 4. I know numbers. Doing the same thing for debt. We want to compute the derivative at the identity. Yeah, determinant of I should always be 1, right? But I didn't insert that because I assumed we want this to be determinant of I for some reason. I don't really know what's happening, Raven. I have like a 1/4 idea of what's happening. Want to compute the derivative at the identity. Well, it just goes to I. But we're going to have a 0 over 0 situation. So we need to do something to make it not 0 over 0, right? We need to write in terms of the characteristic polynomial to obtain something more manageable. It's presumably where the stuff with eigenvalues comes in. Numerator just be a polynomial in T. Yes. But okay, I guess my first question is, T is just a general real number here. And eigenvalues are specific real numbers or complex numbers. So I would hesitate to just like start calling things lambda immediately. We don't need eigenvalue per se. T is the perturbation. Hone your competitive instincts. Ooh. We just need to relate it to the characteristic polynomial. They were honed many years ago. Too old for that nonsense now. Getting too old for this shit. Well, okay, so I could do this procedure on this. I don't know if that's a good idea. It is a good idea. Okay. Lambda. Like that. Determinant trace for it's like I forget what order they go in, but I do know that for a 2x2 it's like lambda squared plus det a lambda plus trace, or maybe that's flipped, but I do know that exists. I assume that was only for 2x2s. It's the idea we're heading for. Okay. I don't know how you do that for a general matrix. It might also make things worse, for all I know. I did that wrong. There we go. That's where the trace goes. I don't know how you would generalize that to bigger matrices, though. I just kind of assumed that it didn't. How much in my life is spending off any stupid attempts for my ex to screw me over? 13 years since the divorce, she hasn't gained a penny. Oh no. Jeez. Do I have an extra 2 in here? Oh, I do have an extra 2. Yeah. 2x2 case should be manageable. I guess we can make that assumption and see how it looks. I have hard imagining... Maybe the constant term will always be the determinant. I don't know how the other terms will break out, but... instead of lambda, we have 1 over t, though. I guess I'll use the XYZ thing that we were doing before. Or I guess it's just trace A. We're doing some freaky math from color code. That's the question there. I'm a little bit lost though. What gaming genres? My favorite game that I'm playing right now is DayZ, which is a survival shooter game, multiplayer. I have a playthrough of Sifu going that I need to get back to. But I also like the gaming, it has been all over the place over the years. I want to get back to Factorio. I've done like puzzle games. But it's normally like DayZ, and then either like if it is a different multiplayer game, it should be like some kind of like meme game. Like I organized like a Mage Arena lobby when that thing came out, and then like single player games. For a 2x2, we have n equals 2. A is constant, so we just have a polynomial in the numerator. Yes. Oh, yeah, n equals 2. I see what you mean with that now. Okay. Oh god, trace and T is, it's a bad combination. Oh hey, that's the cancellation that we want there. Do you follow? Oh, well, thank you. Coming up on 2 a.m. and just not wired for abstract math. Engineering language where I shine. Oh, hey. Fair enough. Yeah, so I do math streams and then I do game streams also. So obviously today's just a math day, but of course I do both. Welcome in though. I appreciate you saying hi. And I hope you have a good night. Is there any minus trace of A? Question mark? I think it's right. Okay. Oh, big stretch. So do we have to evaluate this at the identity? Oh, is it just n? Yeah, I'm worried about that negative sign also. We're already at the identity? Oh, okay. F plus TA goes to I when T. Okay, okay. So this is theoretically the answer as long as I'm not off by a sign, which I might be. What's the general characteristic like for... I just kind of assumed that there wasn't a trace determinant thing for n by n matrices. Oh. I mean, oops, I guess if we're using this definition, it's x plus w. Thank you for this hack? Which hack? Here you see in the computation, let's go into the polynomial characteristic just vanish as t goes to 0. Yeah. Like in the 2x2 case, we've lost half our variables. In bigger matrices, we'll lose way more than half. Whoa. So there is a general formula. I've never seen that before, though. The constant in from lambda to the n minus 1, lambda to the 1, I cannot remember. My eyes hurt. I don't want to keep on studying. Should I keep on going? You should you should at least take a break, it sounds like. Should be the trace of A. Okay. Cool. Tensor algebra. Wish someone would say whoa when they see me the way Don says whoa when he sees a big matrix. Hey, Fizzbuzz. I whenever I see this like wedge thing, I'm like, I probably am not gonna understand what this means. This one I might actually understand. Record Don said as your ringtone. Functoriality? Of all the words that have been made up for the sake of doing math and describing mathematical things, functoriality, for whatever reason, just really stands out. It's a multilinear map, Don. It sure is. I definitely know what that is. Just care about the one in front of lambda to the n minus 1. Okay, yeah. Whenever you can see it directly? Okay. It's the universal property of tensor algebras. What do you expect? Tensor, I hardly know her. That's the only thing I can contribute to that comment. Okay, yeah, I'm not gonna understand that. So, I just computed a tensor. I wouldn't know. Just to figure out one coefficient. Yeah, the only coefficient we cared about was that trace. Everything else goes away. I don't really know what we did, but we sure did it. Raven. Oh, with pleasure. That's a good shade of white. That's a good shade of white. What's this link? The derivative of the determinant of A is equal to the trace of the adjoint of A dA, which is determinant of A times the trace of A inverse dA. It sure is. It is weird that I'm potentially off by a sign here. I don't really know what's going on. It's crazy math. The derivative of a matrix evaluated at the identity. But now we get to draw. Because Raven redeemed a drawing. Okay. Oh, via chain rules of the better thing to look at. Ah. Oh, this is the calculation that we did. Okay. Fair enough. Okay, so I guess let's start by drawing the derivative of the determinant. Yeah, what was the actual derivative determinant? Okay. Derivative of the determinant of A evaluated at I. That's how I'm going to write the notation for this, I guess. Where actually, no, we can also. Okay. And it'll be in a cloud. That's a crappy cloud. It's still a crappy cloud, but it's less crappy. Okay, now creepers. You know, I want to get this right. Let me get a reference picture. Wait. Reddit thread. What are creepers made of? How are the people of Reddit answering this? Leaves. Their texture is based on the first bright green leaves texture. Huh. Gunpowder? I choose to believe that it's leaves. Wait, what? Oh, I didn't copy the image. Ah. Copy image. Okay. It's gonna be hard to make this not look like a dick. I'll do my best though. It's a general way to figure out derivatives in differential geometry from its tangent map. Can I draw a cartoonish representation of any math topic? Maybe? I'd have to think about it a lot. And nothing is springing to mind. Do creepers actually like expand when they blow up? I think they do, right? Like they get fatter. That's not really. It's not really. Okay. I'm gonna draw it in its natural state. But it's gonna be hissing. It's gonna look more like chicken pox than the leaf texture. Using chain rule, your answer you got something like vi det a equals minus det a trace a for the 2x2 case. I think the sign is off. Yeah. Not only that, pretty much the way people in differential geometry do it. Should they want to compute the derivative determinant at any point of GL of n, use some trick that can reduce it to compute a derivative at the identity. You know, we could do like a before and after. Actually, no. Okay, no. I think I know how I can make that look. Happy Nightmares. Thank you for the follow. This would be like the kaboom mark. Kind of looks like a flower. Shouldn't I feel like there should be like a circle. It just like a flower. I don't know. That'll be where the creeper exploded. And then all the stupid math will be just like laying around on the ground all like scrambled. Rest in peace. You know what? I'm gonna give it a gravestone. Math. 2025 to 2025. Put the trace of A? Yeah, sure. It'll be buried in a shallow grave. Oh, yeah, there isn't a brown by default in this. RIP sign error? Yeah. Matrices become a child's play. Dynamical analysts compute derivatives over Banach spaces. So your people use Frechet derivatives under the condition A is a bounded operator. Sure. Whatever that means. You were talking about I'm probably saying it wrong. It's probably French and it's like Frechet or something. I should look up what that means though. All right, how was that, Raven? Frechet? Frechet derivative? 10 out of 10? Hell yeah. Post that in the Discord. I looked at it before, apparently. Not to be confused with differentiation in Frechet spaces. Of course not. Derivative defined on normed spaces. Sure. So the case of a vector-valued function of multiple real variables. And to define the functional derivative, use violate. Oh, okay, yeah, I've seen that. I don't know what it really means, but I've seen it. Finite dimension that's equivalent to the usual definition. Okay. Represented in coordinates by the Jacobian matrix. Shout out. Fancy language for what I was doing? Okay. Alright, fair enough. Unless someone else wants to bring up a topic, I might go back to reading that paper. Yeah, I guess we'll do that. I'll keep that open. Okay. So I did start the stream by trying to read through this paper, Googling my way through one word at a time. I haven't gotten to the actual math part of this paper. So I have to Google like every other word this thing says so far, but it seems like a pretty well-written paper, to be honest. I just don't know the biology of it. In infinite dimensions, a linear map can be not continuous, so you have to be careful. For example, the derivative at x equals 0 is linear, but not continuous in some funky space. That's weird. I never done anything with infinite dimensions. That's like the idea of what that is like super weird. I think I ended on that sentence. I don't remember though. This paper provides an updated mathematical framework for the targeted treatment of cancer, which elucidates the principles according to which resistant tumor cells evolve. Be applied to specific cancers, can be treated with targeted therapy. We consider CML provide guidelines on how many drugs should be used in combination to avoid treatment failure. Oops. Happy to find a fellow paper reading, math doing streamer. Hell yeah. Well, welcome in, Happy Nightmares. I've seen you around in chats. I don't realize that you like math too though. That's awesome. I'm terrible at remembering to give shout outs, but I'll have to go and say hi sometime. Yeah, so my background is I just started on a master's in applied math, and one of the classes I'm taking is it's called Models in Computational Biology. And so one of our first homework assignments is to read through an academic paper that deals with mathematical modeling in some biology thing. And like answers some basic questions about it. So this one that I chose to like read through. Oh, nice. Yeah. I'm usually more of a lurker, but in pretty much all like the math chats on Twitch, I'm usually lurking on them and sometimes typing. They don't really deal with infinite dimensions. They just add infinite zeros and call it infinite. Okay. As for computational purposes, fair enough. Hey, Rex. Shout out to Color, since he promised he'll start streaming. Oh yeah, Color Code has streamed like maybe at least once, but I feel like 2 or 3 times. It's been a minute though. Class example is d by dx sine of nx at x equals 0. It's equal to n. Oh, okay, yeah. But the norm of sine of nx is less than or equal to 1 with supremum norm. Hence, d by dx. Oh, okay. I guess so. Zone, am I going to do stochastic grammars in the class? Not that I know of. I don't know what a stochastic grammar is. Stochastic grammar. Is this like language prediction? I don't think we're going to do anything with languages. We are going to do matrices and Markov stuff, I think. In a different window, I'm going to bring up the syllabus of the class quickly and check. This is something I probably don't want to show on stream, so bear with me for a minute. You can model the RNA with it? Ooh. Interesting. Oh gosh, there were so many types of models here. I'll copy this part of the syllabus out. Paste it in here. Probably not this. Weyler-Laka, root finding, Leslie matrices. Nope. Stochastic models. Electrical membranes and neurons. This time. I don't see it in this. I think did I chop a piece off here? I did. Electrical memory models and attractors, stochastic differential equations, numerical methods. Gurko's circle? So, okay. Ooh, Lyapunov. That was one of the favorite things that I learned about. So yeah, I don't see an explicit mention of that Zone Ranger, but maybe that's somehow captured in some of this stuff. I wouldn't know. Raid to Caller after then? If Caller turns a stream on, I would definitely raid him. Fan function have arbitrarily large derivative? Okay, fair enough. Someone from my university wrote this paper. Oh, really? That's crazy. Ciphering dead languages, maybe. Don't have an official title yet. Applied derived categories with Hodge theory applied to Calabi-Yau manifolds. That sounds cool. Getting thrown under the bus. Just started auditing some graduate courses this fall, hoping it may turn into a master's program. That's awesome. Well, good luck with that. Happy nightmares. What would the master's degree be in? I have a co-professor who would love to work with you, Don. He wants to combine dynamical systems with lean. Ooh, I don't know anything about lean. Yeah, that's like, when I think of category theory, that's like about as pure as pure math gets, in my mind at least. Is it? Yeah. Oh man, it's been a minute since someone's tried their luck at the lotto. It's VIP for 30 days if with a 1% chance. Okay. Stochastic grammars sound interesting though. Colorless green ideas sleep furiously. Grammatically well-formed, but semantically nonsensical. Yeah, sure. Not totally sure just yet. My bachelor's was in cognitive science. I'm looking for work and not finding much, but then, yeah, fair enough. Cognitive science, that's awesome. I'm a fellow person. I majored in applied math, minor in computer science, and I could not get a job with that after graduating. I worked at an HR job for a good like couple of years, and then I came back around to do this master's in applied math. Just because, you know, if the bachelor's didn't work, surely a master's will. This is gambling. It sure is. High energy physics. Exotical exo. Hello? Welcome in. Want to hear something better than cat theory, Don? Chromatic homotopy theory. I'll have to believe you. Chomskyan linguistics? Oh yeah, Chomsky. I know the name. I don't know anything about him. Collars and God mode. Linguistics was fun. I never taken a class on it. No understandable meaning that can be derived from it. Linguistics is kind of cool in terms of like what it says about how people are connected, though. Senseless but grammatical. That's a good name for like an autobiography that like an English teacher writes. In French, we have this dumb statement, ton, 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 which is valid French, but pretty dumb. In English, we have buffalo, buffalo, buffalo. I forget how many. Your uncle shaves your uncle. But buffalo, buffalo sentence. Yep. I thought there was an even longer string of buffaloes that you can make sense. 1, 2, 3, 4, 5, 6, 7, 8. I thought people did even longer. After bachelor's, will I sell out or keep? For masters, will I sell out or keep going for more? Sell out. I'm probably gonna end up selling out. I'm planning to do the intern application for a PhD to see if I get in. It's pretty freaking competitive though, so I'm not really banking on it. I also like I don't really have any idea of what I would want to research, but it'd be cool to have one, I guess. Linguistics is super interesting. A lot of important comp sci stuff came from linguistics, like those trees you see on there. Yeah, this does make me think of like a binary tree. That's not quite a binary tree, but that makes sense, yeah. You've never seen that, Destin? Or something with pleasers or something similar? Oh, I haven't seen another version of this. Linguistics is one of the cognitive science areas. That makes sense. Then, Lux, you live in Buffalo. Well, you should know all about this sentence then. That's cool. I remember you lived in like upstate New York. I didn't remember that it was like Buffalo specifically. Have you seen the new series for Color Cone, Interview with a Vampire? They are binary trees. Okay. What is it, a buffalo? Yeah, but tell me, sorry, it's like a bison. one of these guys. For applied math, it's easier to write papers, right? Probably. I imagine there's a lot more things that you can, like, it's probably easier to find applications of things than it is to create new theory. Like, with applied math, like, you can use some math that someone else did and just apply it to a new situation, and I think that's a paper. I wouldn't, like, actually know, but I think. Okay. Conceptual framework. Understand how resistant mutants... Oh, yeah. Every time I see the word mutants in this paper, I'm going to think of the X-Men, but I have to remind myself that they're not talking about X-Men here. Like, not that type of mutant. Are generated during cancer progression and treatment. We have developed the following conceptual framework. Potential advisors yet? Not specifically, no. Like, I'm going to my class, but I haven't had like a one-on-one conversation with anyone yet. At some point, once the quarter heats up a bit more, I'll probably make a point of going into their office hours at least once. I tried to read some papers from one of the professors that I'm taking who's doing climate science, which sounds really cool. But goddamn, it was so like technical, I couldn't understand what was happening in it. Starting to get along with the professor, he does Schubert calculus. Schubert calculus. Oh, algebraic geometry. What? To be honest, I don't really know what algebraic geometry is. I just run away when I see it. Solve various counting problems of projective geometry. Huh. Weird, like, combinatorics thing. Sounds like. There's a very cool puzzle game that's related to that. What's it called? Schubert was a maybe also. Oh yeah. Look at his tiny little glasses. I think it's a different Schubert, but like, dude, those glasses are so, they'd be so bad to look through. You have no like peripheral vision with those. No, this Schubert is a different Schubert. This is Hermann Schubert for math. This is Franz Schubert. Are they related though? That's a question. Oh my god, I thought his middle name was Cannibal, but no, it's Hannibal. This is a very brief Wikipedia page. I don't know. The song is also awesome. Is it gonna be a piano? I don't know. The musician, right? I guess so. Cannibal, X-Men, yeah. I have a very simple mind. So these different Schuberts all this time. Okay, 50 minutes is a little bit like long to watch on stream, but that could be an interesting watch tonight. Schubert's harmonics was because of calculus. The puzzle's the interesting part. Okay, oh, that's just like a minute or so. All right, we can watch this. Okay, I I don't see where the calculus comes in. Um, like, or why it's called calculus and not something else. Well, yeah, I want to see a derivative. Why isn't this Schubert's fucked up shapes? I don't know. I'll give that a watch. Fully after the stream. She's moving pretty like quickly though, so I feel like I'm gonna get lost. But what are you? Oh, one of your favorite Schubert pieces. I assume composer Schubert. You know what? Sure. Let's listen to a bit of it. That just means a way of computation. Oh. It's actually pretty nice. That's what I wanted, Dessen. I want to take the derivative of a triangle, okay? If we can take the derivative of a determinant evaluate at the identity, we can take the derivative of a triangle. It's pretty low key, but for classical music, that's not bad. I don't really know the first thing about like actually appreciating it, but this is sort of a bop, as the kids would say. Oh wait, this playlist has been looping for a long time. I need to change the playlist. We'll go to this one. This is the one with a bunch of The Midnight. But first it'll be the song. The number of this puzzle of a certain size is like the coefficient that appear in the intersection product or something like that. Have I ever heard of simplicial homology? I sure have not. Double integral of a triangle? Okay, so simplicial is tedious to compute, but the best intro to homology. Fair enough. Differential of a triangle is 0 in simplicial homology? Oh, okay. I'll have to take your word for it. But it is possible, is the point. Growth rate of cells is L. Death rate is D. Hi, FA. Oh, did TikTok use this song? I just like Spotify just suggested this song to me, and I liked it. I don't use TikTok. Hope you're doing well, FA. This is biology. Sounds so spaced out. I love it. Yeah, I like this song. The Hilbert's 15th problem thing, it said it was invented by Alan. It's just Newton, right? And Terence Tao. That's awesome. TikTok's song alarm too old. There's even this song with spinning cats. I mean, that doesn't sound so bad. I like cats. Condition L greater than D corresponds to a clonal expansion. What is clonal? I don't like looking at the AI answer, but it's so convenient. I've been wondering if I should just embrace AI when it comes to learning about biology. Or just like to learn what these like random words mean. Okay, so clonal means genetically identical. What about dogs? I like dogs too. I'm more of a cat person, but I also like dogs. You know, but color cone speaking. You only just started. You'll get there, Codify. Embrace Zach. Was there a Zach mention? I definitely agree. Embrace Zach, but how old is this paper? Oh, she's one who went to your university. 2005. Oh yeah. Well, I hope you feel better, Codify. Zach Day. Oh, Zach. I get it. Yeah. e to the 2 I AI. That doesn't e to the 2 AI. It's gotta be a catchy way of saying that. Cancer detected when the colony reaches a certain size n, at which moment the therapy starts. For it to end as the treatment size. That sounds like a terrible term. The treatment size makes me think of like the dose of a drug. But it's the size of the colony at which treatment starts. Never finished what you're saying before. Oh yeah, I remember you having like a cut-off chat, but I thought like, oh, you know, maybe I'm just like misunderstanding it. As soon as the consistency is consisting, we go into the mood. Hell yeah. My wife hates the midnight. The sax is horrible. 80s sax. I can't help but like it. Yeah, all of his songs kind of sound the same, but I don't mind the song, the sound. I like all I've done is I took that last song that we just listened to that I really like, and I just put on to the Spotify radio, and for whatever reason, Spotify just puts a shitload of the midnight in there. Family Guy's chemotherapy joke? I don't remember that one. Oh yeah, Dr. L, I definitely have permission. Oh wait, or do you mean they actually have they like given a blanket thing? We need more spaced out music. People trying to investigate pros and cons for treatment versus body pre and post chemo. I think it. I think they're modeling how a multi-drug treatment can help overcome resistance. I think that's the point of this paper. Then it's not DMCA. Oh, I mean, uh, I play copyrighted stuff all the time. There's a way that you can like get away with it, for lack of a better word. Do I look bothered? I don't feel bothered, at least. No chemo jokes, please. Oh yeah, I'm sorry, Destin. I won't play the video. I've had family who have passed away from cancer. It's no fun. I found a tiny but awesome research gig last month, 30 hours in total. One of the project investigators said, "What are your future plans? Grad school? Hey, you want to come audit my graduate design course? I think you benefit from some design elements." Oh, that's awesome. Making a connection like that. Well, I hope it turns out to be as useful as they say. What's the workaround? You can get it so you can split your audio in OBS so that the audio that's sent to the live stream is different from the audio that's sent to the VOD. And if you only play the music on the live stream and not in the VOD, you don't get caught. As far as I know, people don't really get caught. I never heard of anyone who has. So if you were to go and listen to the VOD of my video, you'd only hear my voice and not the music. It's a bit of a pain to set that up. So it means you have to split your audio, but it's not like the worst thing. It'd be cool to do some computations where we figure out how much treatment we can do to avoid body deterioration. I think there are quite a few papers like that out there. So the professor provided a list of papers that you could look at, or you can choose your own, but I just used one from the list. And I think there was one on chemotherapy specifically that considered the impact on the patient. Okay. The effective therapy is modeled by the drug-induced death rate, H, which shifts the balance of birth and death such that the colony shrinks. That is, the net cell death rate is now larger than the birth rate, D plus H greater than L. Okay. If all cancer cells are susceptible to the drugs, then therapy would inevitably lead to eradication of cancer. However, in the course of cancer progression, mutations can lead to the generation of cell types that are resistant to the drug. It's assumed to occur with a probability U upon cell division. Before the tumor is treated, the mutant will behave identically compared with the wild type. Okay, yeah, fair. During therapy, however, the resistant phenotype will proliferate, whereas the wild type will be killed with a rate H. Yes. The resulting treatment failure can be countered by combining several drugs as demonstrated effectively with viral infections. They say antibodies grew against cancer cells treatment, I think. Yeah, I don't know if they're called like antibodies, but like this paper's talking about like drug resistance, I guess, if that's what you mean. Too many words, where's the math? We got a bit of biology to get through before we get to the math. But look, there's a giant directed graph here. There's a regular like plot there. I think the next page will be a bit more mathy. Totally unexpected turn for me. It's extremely interesting. It's extremely multidisciplinary in a way. My science background fits great. That's awesome. Yeah, I guess like I should have asked that, but like, does design like engineering design or like I assume it's some type of like engineering type of design rather than artistic design. Such combination therapy is included in this framework. In our first model, we assume a mutation that confers resistance to one drug does not confer resistance to any of the other drugs in use. This may not be the case for all drugs, such mutations, and these effects have to be accounted for in further modifications of the model. Okay, so one of the questions was, what simplifying assumptions do they make? And this is going to be one of them. I'm going to copy this into my thing. And I'll clean this up and put it in my own words later. With these assumptions, to become resistant to N drugs, the cell has to accumulate N mutations. Okay. These mutational processes can be presented as a combinatorial mutation network. Example of which is presented in figure 1. For simplicity, we assume mutant cells that are not resistant to all drugs in use are killed the same rate as wild type cells. Let's go look at figure 1. Because they made a reference to it, so let's see if we can understand it. So totally unexpected turn for me. Oh wait, yeah, I read that one. Doctors trying to trick the patient's immune system against cancer cells, unrelated to this article. Oh, okay. That's a cool idea. My community college professor gave me the advice of not get stuck in one area, so it's good to be open to do anything or all. Why not? Yeah. I mean, I think that could backfire if you're like too general, but I guess it depends. Like, yeah, I guess it depends. We have a dancer slash choreographer in my class, engineers, fashion designers, production designer. Oh, that is everything. Wow. I mean, so maybe you don't know the answer to this question yet, because I think it only just started. But like, surely that like there's something that's unifying all those types of designs, which is what you're learning about. Like, how do you possibly learn about all those different things at once? All right, can we understand what figure 1 is saying? Mutation diagram corresponding to 3 drugs. Each node corresponds to a phenotype. The binary number above each node identifies which drugs the phenotype is resistant to. And I think phenotype is just like a certain gene, if I remember right. 011 means this type is resistant to drugs 2 and 3, but not to drug 1. Okay. The leftmost type 000 is fully susceptible. The rightmost one, 00, would be like the wild type. Rightmost one is resistant to all 3 drugs. Mutation rates are the marked above each arrow. The notation below the nodes identifies the variable used to describe each phenotype. See supporting information for details. Hit that on why it's so neat. Somewhere we're studying all the same stuff and it's applicable to all of us. Yeah, that's kind of wild. I wouldn't expect a class like that to be able to make much sense. Phenotype is the expression, the body. Okay, thank you. Do they explain? So they have the binary numbers at the top. What are the X's on the bottom? Maybe they explain that somewhere else in the, like, so somewhere up here. U is the probability of mutation. They said that somewhere in the body. So if they get a U1 mutation, then that turns to 100. That makes sense. Then if that gets a U2, it'll be 110. Okay, yeah. I think I know what's happening with this digraph. Genome type is the DNA. Oh, that makes sense. These mutational processes can be presented as a... Oh, yeah. Turns out this complication does not alter our results significantly. Okay. The model is based on mathematical analysis of stochastic birth and death processes on combinatorial mutation networks. The approach is described in the supporting information, which is published on the PNAS website. Get the main text accessible for a biological readership. Okay. This is not the fun part of biology. What in the diagram is that? Okay. These like 3-digit numbers, the zeros and the ones, denote resistance to one of the 3 like different drugs that they give at once. So if it's 000, it's not resistant to any of the 3 drugs. If it's 111, it's resistant to all 3 drugs. And if it's like 100, it's only resistant to the first drug. And so there's a probability of just randomly mutating resistance to that drug. And that's what these U's are. That's what this diagram is kind of representing. How like your original wild type of cancer, like the different paths it can mutate to have resistance against all three drugs. Because it can, you know, evolve them in different orders. The first couple of weeks we discussed what design research is. Spoilers, it's complicated. For example, you're not aiming for replicability. That sounds weird. Okay. We had to settle Aristotle's forms in phenomenology? Wow. I've heard the word phenomenology. I'm probably saying it wrong, but I want to see phenomenology. But fuck, I can't spell that. I'm going to copy paste what you wrote. No, I just copied what I wrote in the... Oh my god. Science of phenomena as distinct from that of the nature. That doesn't help me. Objectively investigate the nature of subjective conscious experience. Okay, that makes sense. It's like the spirit versus the body is what I'm imagining. They're focusing on like the spirit, but they're probably not doing anything spiritual. You always stutter on that word? Phenomenology. But okay, I think I did it right just then. That voice sounds so weird. I don't know why that sounds weird. It sounds like AI. What is the link with dynamical systems? I don't know if I actually chose one that has a dynamical system in it. They might not use that dynamical system. I don't... that is that a derivative? Such as a sneaky delta. No, that's not a... Delta is a fraction. I maybe should have chosen one with dynamical systems because that's what I like, but I just think I also like this. I guess when I say that dynamical systems, I kind of just mean like modeling, and those were the things that I learned to model with. But I'm not sure this does have a dynamical system in it. Where was I? Okay, yeah, we're here. We'll explore the principles according to which resistant mutants are generated during the pre-treatment growth phase and during therapy. In particular, we investigate the chances that resistant mutants pre-exist before treating a tumor of size n. With respect, it is key to examine the number of cell divisions that occur during the growth phase until n is reached. Makes sense. This is roughly given by script n equals nl divided by L minus D. Okay, remind me what these are. N is the treatment size, which is the size where a doctor notices the tumor and treats it. L is the growth rate of cells. D is the death rate. So growth rate divided by the difference. What is that doing for us? Paper I gotta present on soon is about interfaces and cybernetics. Wow. Interfaces are applicable to so many areas of design, maybe all. Huh. What a wild class. Like, I... That sounds like a really interesting class that would, like, change the way that you see stuff. From the way that... the way that you see the world. From the way that you're talking about it. Which sounds awesome. It's doing that to you. It sounds like a good class. The number of cell divisions. If D is 0, you get just N. That doesn't make sense. If no cells are dying, shouldn't you need way less than N cell divisions to reach the... Oh, wait. Oh, wait. A tumor of size N. Okay, yeah. Number of cell divisions that occur during the growth phase. The number of cell divisions. Yeah, I have no intuition for why this formula is right. Huh. Just wild because I'm in my late 30s and suddenly shit's changing real fast in the last month. I mean, that's good, you know? Being an eternal student. Keeping an open mind. I'm still like, okay, if none of the cells ever die, why would you need n many cell divisions? Because wouldn't that just mean that, like, oh, wait, does that make sense? Okay, wait. Age is just a number in Einstein math until he died? That's true. So wait, if I have one cell, it divides into two cells. Those two cells divide into two more cells. Oh, okay, so I was going to count this as 3 divisions. Or I guess, well, no, 2 divisions, right? But are they going 1, 2, 3? And 3 is approximately 4? if none of them die. This feels like something that would have a name. And it might be worth it to try and find out what that is at some point. But for now, it might just be more productive to accept it and move on. I feel like grad school is learning about how to teach yourself without the need for a class or a teacher. I mean, that would make sense because that's what research is. Teaching yourself and forging your own path. My other course is a neuroscience art course, which is also amazing. That sounds so weird, but still like so awesome. Neuroscience art. I mean, I'd be sure to hear about that too. This is really just a thing that I have going on in the background while like the thing I really enjoy streaming is just like talking to you all. The number of cell divisions, yeah. On the other hand, if D is close to L, many more cell divisions are required to reach size N because a high death rate cancels the effect of cell divisions. If D is about L, this is a small number. Okay, and dividing by a small number gives you a big number. Okay. For convenience, we'll call the scenario where D is about L a high turnover cancer. In contrast, we'll call the scenario where D equals 0, D much less than L, a low turnover cancer. Following, we will first examine the emergence of resistance against a single drug and then expand the analysis to include the use of more than one drug. Okay. Don art too. I art so hard. Yeah, we just did the one earlier that Raven redeemed. Evolution of resistance against a single drug. Consider use of one drug only. We determine the relative roles of the pre-treatment and the treatment phase for the generation of resistant mutants. In other words, how important is the pre-existence of mutants? First perform in silico experiments. Wait, like in silicon as in computer chips? No way that's a real that's a real phrase, I guess, not word. Computational simulations. Oh my god. This feels pretentious to me. I don't know. This paper so far has not been pretentious at all, and I don't think this really is pretentious. I just don't like fancy words when you could have just said simulations. What if you set the mutation rate to 0 right after the treatment starts? Mutations can be generated only before therapy. Calculate the probability of treatment failure in this setting, which we define as the probability that the cancer escapes therapy due to generation of resistant mutants. This paper is better than drugs. It's better than a combination of 3 drugs. This is denoted by P1 up. The up symbol indicates that we look at the contribution of the growth phase to mutant generation. Whoa. We gotta calculate the probability of treatment failure in this setting. Okay, so the probability of treatment failure when you have one drug and only look at the contribution of the growth phase to mutant generation. Okay. Next, we set the mutation rate to 0 in the pre-treatment phase. Wait, what? I thought you were doing that in the second phase. Oh, well, okay, next. Never mind. Ivan, thank you so much for the raid. Welcome in, everyone. My name is Don. I do math help streams. I also do video game streams. What I'm doing right now is I just started on grad school for applied math, and so one of my first homework assignments is to read through an academic paper and answer some questions about it. And this is the one that I chose about drug resistance in cancer. Because they're doing like some mathematical modeling with this. So I'm just trying to read through it and understand it. It's kind of like a downtime thing until someone wants to ask a question, though. For anyone who's here on my end, please check out Ivan. He has an awesome stream. Physics, philosophy, all that good stuff. It's a great just listening experience. But yeah, Ivan, I hope your stream went well. If you want to just raid and run, feel free to. But if you're sticking around, I'd love to hear about what you were talking about. Plus a banger background soundtrack. Yeah. So yeah, I've been trying to read through and understand this paper here, talking to Happy Nightmares about the classes that they've been taken. Yeah, it's an art course taught by a neuroscientist, so we get lectures on neuroscience, which are all a review for me. Then we have to use science to do art, which is new for me in a post-secondary setting. Yeah, that sounds wild. Culture stuff mostly? Okay, fair enough. Today's Bring Your Own Drugs Day. Exactly, yeah. BYOD. So yeah, what has the paper been doing so far? It has this like cool looking probability tree graph that shows how the probability of cancer mutating resistance to three different drugs. So the binary numbers, like the zeros and the ones here, denote resistance to one of the three drugs. 0 is not resistant, so you start here. 1 is resistant, so 111 is resistant to all three drugs. And these U's denote like the probabilities of developing that particular mutation. So a particular cell will start out with no resistances, and then it might randomly evolve the mutation to the first drug, so it'll go up on this path here, become 100, and then it could get resistance to one of the other two drugs and follow the other path. And I guess, I mean, this graph implies that it's a guarantee to get resistance to all three drugs. That probably won't actually happen. Maybe it will happen. I don't know. We're trying to find that out. Yeah, so this is for a class called like computational models in biology or something like that. So it's about the intersection of math and biology, and it's a part of math that I am really interested in learning more about. I know almost nothing about biology though, so I'm pretty much almost every sentence that I've read so far in this paper, I've had to Google at least one of the words in it. But that's just how you learn. So this paper is, we're just around this section here where they're looking at a simpler case where you start by looking at the probability of treatment failure when you just use one drug and the mutations only happen before you start treatment. Thank you, Rex. Everyone needs a crappy bio support sometimes. Oh wait, you know what? It's getting darker. I can turn on my background lights. I still need to automate these. I've been much too lazy to get these integrated with Twitch again. You can kind of see them. It's a little bit too bright. But I used to have background lights that you could control with channel point redeems and change their color. I've since bought a different light that can do fancier stuff like little like light shows. It doesn't show up as well as I hoped in the background, unfortunately. This is the Halloween preset. Well, why is it pink? Like, I don't think of hot pink when it comes to Halloween. It's a better one. We could do fall. Okay, that's not bad. Let the clubbing bit begin. Yeah. So yeah, at some point when I'm not lazy, I'll figure out how to get this thing integrated with Twitch. Okay, I just read this sentence here. No, I read this sentence here. Okay, so in the first situation, they only allowed mutations before treatment starts. In the next situation, they look at mutations only after treatment starts. And so that's P1 down. The use of arrows is really odd to me for this. I don't have a better idea, but happy hour begins, drinks all around. It is 6 p.m. I'm planning to have a drink tonight anyway. Oh wait, why is my cam blurry? Wait, what? Does my hotkey not work? Am I doing the wrong hotkey? Wait. This is concerning. Why isn't my hotkey working? I know how to fix this blurry cam thing. I'm concerned why my hotkey isn't working. Oh, did I do that? Oh wait, it's no longer blurry. Is the hotkey in OBS? Oh, and oh. Yeah. Okay. So my issue, I did this hotkey through OBS, and when OBS update 32 came out a few months ago, I had to nuke my OBS and remake everything from scratch, and I forgot to set up that hotkey. I really never needed that hotkey this entire time? That is crazy. Control 8. Control 8. Apply. Do you work now? Really? Oh, does it have to be for all scenes? Sorry, I really shouldn't be doing this on stream. But like, once my... Like, it's on my mind right now. I won't be able to stop thinking about it. I think I have to do it for all the scenes at once. Or I can't do it globally. I have to do it individually, which is really annoying. Hey, there it goes. Okay. No, it's not. It's 9 p.m. Dang, you got me. It's not 6 p.m. It's 9 p.m. I can see right on my clock. Thought we drank too much? OBS drug resistant? It is. OBS, it evolves to resist my hotkeys. My OBS has been pretty messed up ever since they updated that. That's not the only thing that's even wrong with it. 9 prime ministers? That's a lot of prime ministers. Oh my god, Syntax, it is late for you. No, 9 p.m. like the time. $4 a.m. in fact. Oh my god. That's a lot of... Is there a minister that starts with A? I can't think of one. Finish the course book for my limits course. Noise? Are you just like working super ahead? You're a major night owl? Oh, nice. I conk out. I'm not good at staying up late. So I'm here, but I'm a vampire. Oh yeah, Rex, I forgot. Yeah, it's also super late for you too. I pulled an all-nighter once in my life. I forget why though. I don't think was I doing anything? No, I think I couldn't sleep. But yeah. Very bad at getting to bed early, like kind of extreme. My sleep schedule kind of goes through phases. So sometimes it's good, sometimes it's bad. I have a class that starts at 8:30 in the morning, and that's been kind of, even that's kind of rough for me to get ready for in time. I usually try to be in bed at midnight. I don't always accomplish that, but that's my usual goal. Not super ahead. I did half the first weekend, was on par for a bit until I did the rest, like 30%-ish. Okay, that's still a lot. During summer vacation, it wasn't all too common for me to come home around 8 to 10 a.m. What? Were you just out partying? That's wild. No, with your partner? Okay, okay. We walked to places? All right. I guess you do have to enjoy your summer when you live in Finland, right? ADHD doesn't seem to help me going to bed. Oh, that makes sense. Yeah. That does sound like it would make it harder. And talks, I like to talk to them. Like, enjoying speaking with your partner, that sounds crazy. I mean, that'd be weird if you're just like, well, it doesn't have to be weird, I guess. But if you're just like walking in silence. No, I mean, I guess it depends on the relationship. That doesn't have to be weird. Next, mutation rate's 0 in the pre-treatment phase. Mutations can be generated only during therapy, which we can evaluate. Corresponding contribution to treatment failure, P1 down. Turns out for realistic treatment regimes, we have P1 up greater than P1 down. The probability of failure, of treatment failure, is higher if it can only mutate during the pre-treatment phase versus only mutating during the post-treatment phase. So that probably means that the number of mutations before treatment is more important than the number of mutations after treatment, which feels like it makes sense. The earlier the mutation happens, the bigger impact it would have in the number of cells. That's my guess. Also, like during the summer, the day was unbearable. It's generally the best way to go about it. Yeah, okay, that's fair. I mean, I feel like unbearable for you is probably average for me back when I lived in California. I don't know how hot it actually does get there, but yeah, that's fair. It is funny that now that I've moved to Seattle, so I'm like a fair bit more north of where I used to live. I'm the one who's always like wearing jackets and stuff, and I see other people just walking around in shorts and t-shirt. Meanwhile, I have like a coat on and pants, and I'm still cold. Can't stand any heat. Cold I can stand. I do not like the heat. I haven't truly lived somewhere where it's cold, so I can't say that I'm better with the cold. But I really hate the heat, and that's like one of the main things. One of the reasons I wanted to get out of California. So I'm gonna try living somewhere where it's cooler. The generation of resistant mutants takes place predominantly before treatment starts. Well, this is saying that? Really? Oh, okay. Okay. Maybe, yeah. It's not a bad song. One time for a bit, I came to school in shorts during winter where the snow was up to my socks. Oh my god. I probably I could not do that. Can you ask a question? Yeah, of course. When did it become like nearly 5 hours of streaming? Oh my god. Per kele? What does that mean? Finnish word meaning evil spirit in a popular Finnish profanity. Like, damn. Oh, much more profane. That's cool. The most internationally known Finnish curse word. Perkele. She says it so like airily, like almost like it's a spell. That's fun. Watch a video of a man who lived in the middle of nowhere in minus 72 Celsius? What? What's the coldest? Okay. What is the coldest recorded temperature on Earth? Wow, negative 89? It was right there. Dude, being in Antarctica would be so crazy. I've looked into like what it would take to go there before, and it's actually like the average person can do it if you get a job there. But yeah, I didn't realize that we got the temperatures this cold. In Kelvin, it sounds pretty hot, though. Do you know if there's a neat solution to y to the n equals y? I assume that's nth derivative, not power. And is there config where y of x times y of minus x equals related to either 1 over trig functions or tan? Does it? Why triple prime? So for the nth derivative of y, you can always I'm pretty sure you can always just assume that y is e to the rt, and you can substitute that in and get a polynomial of degree n. Because y to the n equals r to the n e to the rt. And not y to the n, but, you know, nth derivative of y. So if you plug it in here, you'll get r to the n e to the rt equals e to the rt. So rearrange stuff, r to the n minus 1. Oops. E to the rt equals 0. E is never 0, so we just consider r to the n minus 1 equals 0. And I guess we get the nth roots of unity. That's kind of funny. I never thought of all that. That's kind of... Honestly, that's kind of mind-blowing to me. That this differential equation is basically the roots of unity problem. Because R can be complex is the issue. So we can look at it for tangent. So I'm not sure where you're getting, or sorry, for triple prime. So I'm not sure where a tangent will come from. We're going to end up with r cubed minus 1 equals 0. We'll get the cube roots of unity. E to the I 2 pi over 3. Well, 1, of course. I'm just solving this geometrically right now. I think 4 pi over 3 is the other one. Because 4 pi over 3 is right there. Then when you multiply it by 3, I think you end up... I should do this in stages. Go around again, end up there. Aha, yeah. Then do it again, you end up there. Okay, yeah. So I think these are the solutions. And so then you get a linear combination of these three solutions. So y is c1 e to the t plus c2 e to the 2 pi over 3t c3 e to the I 4 pi over 3 t, and then you use Euler's formula. Just a hunch from graphing stuff. Isn't there some more intelligent way of grouping this? No. This is basically it. Like, we can get rid of the I here by bringing it into C2. It's not that important, though. So you're claiming you can make this look like tangent, depending on the parameters? I imagine that's maybe the e to the, like, the first term may be tricking you. Shouldn't there be an exponential? Did I mess up? I think not in this case. If there's been a 2 here, I think we would. I think these are purely imaginary. But we can go to Wolfram Alpha and verify this. We don't have to guess. Oh. How hard did I mess this up? What the hell? What did I do wrong? You might kind of look. That's why you're thinking the nth case might help you. I mean, you'll have n many solutions in the nth case, which doesn't have to be a bad thing, I guess. Actually, wait. Well, we can verify x cubed equals 1. I know what I did wrong. Okay. This is just R. If I wanted to insist on this polar form thing, I would end up getting e to the, or sorry, e to the I 2 pi over 3 times t. But at that point, it's just easier to use the rectangular coordinates. So yeah, you're right. Let's just take Wolfram Alpha's solution at face value, though, because there's no point in doing this by hand. Class I've taken are all pretty cool. Yes, I'm really enjoying them so far. It hasn't been academically very tough yet. But I think they're all really cool. Especially for the complex analysis class that I've been the most like nervous about. The professor for that seems really cool, which is good news. My professor said the limits course was the hardest part of the real analysis package. Hard to believe. Really? I mean, epsilon delta is definitely the most difficult real analysis thing that I've done so far. I still don't understand epsilon delta, if it's like about that. The real analysis definitely gets even harder the deeper you go into it. Oh yeah, how many students are taking? The classes, they're a little on the big side. The smallest one, the math bio class, is maybe 20 students, but the other ones are like 30 or more. The biggest one is scientific computing. That's like probably closer to 40 even. Yeah, it's not huge. It's not like a massive lecture hall or anything. The biology class is going to have a group project, which is good or bad, depending on the group. So syntax here, do with y of x times y of minus x. Like, do you mean like let y equal some other function, like with this form, and then try taking n many derivatives of that to plug it in? This will probably only work for certain types of functions. What would a function like that look like? I guess like minus x squared is a possible solution, or a possible like thing you get with that. Or maybe it's like an integrating factor idea almost. If y of n equals y, or sorry, you can multiply each side by y of minus x and try to do some product rule magic with that. First solve that for y, and then do that to it. Oh, okay. Oh. Okay. So I have to say with the roots of unique stuff? Okay. Yeah, this work unfortunately was completely wrong, but I did the case the completely different way. YQ, or third derivative of y equals y implies... Oh. You're using like differential operators there. I bet that's correct. It's, if it is correct though, it's for a reason that I haven't learned about yet though. The physics department wants to recruit me. Because it's definitely a thing in in math where like the stuff that I've been learning about the complex analysis stuff, like we're starting to get into like differential operators where like you might define some differential operator that's like it takes a function as input and it gives you back like the second derivative plus the first derivative or something like that. And that's what your work there reminds me of. And I bet there's some justification for why that works. I just haven't learned about these things enough. But that does get you the same polynomial as I got here. Because that's just the difference of two cubes, so. You'll end up in the right place, at least. For reasons that I can't confirm are right. Do you love the Swift operator? It's like legit almost never okay to use, but it's so much fun to try anyway. Swift operator. Question mark, question mark? No, this is for Swift, the programming language. Oh, shift. Like a bitwise shift? This looks like the thing you're talking about. Okay, yeah. Oh, okay. Yeah, the thing you do with the delay differential equation. Baker's map? Whoa. We got plaid? Math has invented plaid, everyone. Kneading operation that bakers apply to dough. Dough is cut in half. Two halves are stacked on top of one another and compressed. It's not cut in half, but yeah. You saw it used in Ramanujan's master theorem's proof. Oh, interesting. The shift operator? Oh, yeah. This thing here is definitely past my highest math. Although dynamical systems is something that I want to learn more about. Horseshoe map. I just like things with funny names. I don't know. It is a chaotic map, yeah. Looks like that print Canadians have for some reason. Yeah, that's plaid, like a plaid shirt. These math have such funny names sometimes. Oh yeah, there's some really like memey math names. There's I promise this won't show anything weird. But there is the Harry Ball theorem. It's a real thing in math. Yeah, I have a good couple of plaid shirts. Yeah, the Cox Zucker machine. I have it clipped from when I first learned about that. Chicken nugget theorem. But yeah, even besides these meme ones, there are like non-meme things that are still super weird. Yeah, imaginary numbers is another like weird one. Cox box model? I've not heard of that one. Just to be safe, I'm gonna hide my screen. Okay, it's nothing. It's getting me weird, like not weird, but performance rowing, I guess oars and stuff. Box Cox transformation. I guess this is what. Also, welcome in K-Pars. Yeah. Some things are intentionally named to be dirty, which is what my mind went to, but there are a lot of like non-dirty math terms that are just super weird. There's a whole video I just recently watched about the math term almost everywhere, which sounds just so imprecise and meaningless, but it actually does have a meaning. The stream is sponsored by Manscaped. Transformation of non-normal dependent variables into a normal shape. What is normal in statistics? Oh, yeah, duh. It's a normal distribution. Okay. Yeah, Gaussian. I was thinking of normal like perpendicular. We also like to reuse words for completely different things. Or like group. Group in math means something completely different. Or algebra was the worst one. I took a linear algebra class not knowing what linear algebra means, and I was in for a rude surprise. Because up until that point, I'd only taken like algebra 1 and 2 in high school, and that's like parabolas and lines. And linear algebra was completely different. A standard deviation, which is width parameter, can be thought of as an L2 norm. Ooh. That's cool. I know slightly more than nothing about like the LP stuff. That is cool to hear though. And also, K-Pars or anyone who's lurking in chat. So whenever I see a new face, I try to remember to let them know that there's more math streamers than just me. So in case people in general are interested in math streams, there's a whole bunch of people who stream about math, and I just like to let people know that this niche exists because it's a relatively new niche on Twitch to have this many people in it. There have been math streamers for like a good like at least like 5 years or something, but I think it's like been a little bit different the last like 2 years with the number of people who have been doing it and how much we're like talking to each other. So I just like to give a little like shout out whenever I see new faces pop in. That's cool though. Thank you for teaching me about that. Oh, there's also a Cox ring, which is seeing this person named Cox reminded me of that. I don't know if this is the same Cox. It might be a different Cox, but there's a mathematical object called a ring, and a dude with the last name Cox invented a certain type of ring, so it got named Cox ring. You also on pure math that came in from Ivan's raid. You do epidemiology and biostats. Oh, nice. Yeah, I wanted to learn more about both of those things. So yeah, I just started a master's degree in applied math, and so reading this paper is part of my homework. Grothendieck playing with Cox ring, yeah. Started doing math on Twitch when I started tutoring high school math. You love it? Oh, nice. That's awesome. I mean, I was waiting to check out your stream before, but now like doubly so. As in welcoming community. Yeah, it's. I mean, I'm not talking about myself here, but like the people in the community are just like really awesome, I think. And I think very like not pretentious when it comes to talking about math. Wrapping up a master's in machine learning. Nice. Took math modeling for communicable diseases last winter. That sounds like a really cool class. That's awesome. Good luck with the rest of your masters. Okay. I was just puzzling over this part here. Treatment phase becomes important only for the generation of resistance. Oh, what is H? H. H? Are there any H's? Oh, here's H. Drug-induced death rate. Okay. More saxy music. Mm-hmm. You don't even have to ask who this is, because we just know it's the midnight. Anytime the sax comes in. The treatment phase becomes important only for the generations of resistance in the unrealistic case where H is less than or equal to HC, where HC is defined as 2 times L minus D? What? Two times L minus D. H is 2 times L minus D here. I don't know. There's a lot of the subtleties of most of this are just kind of lost on me, but let's plow through. Kind of regret though I accidentally left the math tag on my stream while I didn't stream for a couple months. Like some math people might pass me by now. I definitely because I stream games too, and I don't bother changing my tags because I'm too lazy. So I've probably confused some people when they look for math and see me like fighting zombies and stuff. But no, I mean, I found out as long as you have the math tag and you're streaming on Twitch, people will like trickle in. People, the math community here generally knows to like just search math in the search bar, because there's the math category, but I think it's because there's a video game called Math and we just kind of hijacked it. And some people stream in science and technology, someone just chatting, and probably something else that I'm forgetting too. But I wouldn't feel bad about like keeping that tag on. Lacking subtleties, let's plow through anyways, been my running phrase over the last few weeks. Yeah. Yeah, it's kind of funny because I feel like normally the tags don't mean much, but in the case of math, it does seem to be a big help. Under this condition, treatment is very ineffective. The drug-induced... So this is the drug-induced death rate is less than twice the effective growth rate. Okay. I'm calling this effective growth rate. I don't know if that's the proper term, but... Life rate minus death rate. I don't know. So the drug needs to be at least twice as effective. I feel like I'm not comparing the same thing here, but yeah. Mushroom all attacks have 0 or 1 hits, the math one has 5 or 6. Yeah. Well, let me see. I haven't checked mine in forever. But that's basically what mine is like too. Because I've hardly been checking my analytics for a long while now. But you have me curious. Okay. Math. 16 views, 153 impressions. English, 1 view, 3 impressions. Best beard on Twitch, 1 impression. Someone searched for best beard on Twitch. Dude, this is pulling its weight. I'm glad I had that tag. Educational, 1 impression. Paul's online notes show. Stutterers rise up. Tutor. All right. Oh, hey, this looks different now. They've updated this since I checked it last. Views from Twitch. Oh, this is cool. Followers, other channel pages. Is that like raids? Browse page. Oh, man. Oh, yeah, of course software and game development gets way more traffic than math. What am I saying? Thanks for the follow, K-Pars. Facebook? Who's watching me from Facebook? Huh. It's kind of wild. Anyway. Effective growth rate both would work? Okay. Or net. Okay. Under this condition, treatment is very ineffective, such that the number of cell divisions during treatment is higher than during the growth phase before treatment. Yeah. I know. I at one point I was gonna like do some data analytics on stream of just like my Twitch data. I didn't get around to actually doing it, but I think that could be kind of a neat stream. Treatment is very ineffective, such as the number of cell divisions during treatment is higher than during the growth phase before treatment. Cell divisions during treatment is higher. Huh. Okay, yeah. The time it takes to eradicate the tumor by drugs in the absence of resistance is larger than the age of the tumor upon start of therapy. Okay. This is not a likely scenario, therefore we conclude that for all realistic cases, resistance develops before the start of the treatment. That's a wild... It makes sense, I guess. It's kind of wild that that's true. It develops resistance before it's ever treated. Yep, 36 followers on Twitch, although I never streamed. Must be bots. I mean, I was definitely lurking on Ivan the other day, and I saw him like give you a shout out. It's like, oh, that's funny, even though you don't stream. That also means if you ever do stream, you got a little, like, boost there. So I guess, you know, you're everyone's favorite, like, guest star on streams. Blame/think Ivan. Combining the growth and treatment phases, we can calculate the overall probability of treatment failure as a function of treatment size n. We have p tot, p total. So wait, combining the growth and treatment phases, we can calculate the overall probability of treatment failure as a function of treatment size n. Ooh. What do you mean? Koroleva Bitov, thank you for the follow. What? One minus one minus... What the hell is happening in this formula? Is it important to try to understand where this comes from? I don't know. I once told a girl I want to run continuity and differentiability tests on your curves, and she blocked me. I probably would too. Welcome in though. Test the concavity of your curves. It's not bad. I don't think it would get a very good response from almost any woman, probably any, but it is funny. I'll give you that. I've seen that structure in the case of being selected in a sample over n samples with replacement. Really? I bet this isn't that much different. It's kind of funny. They don't really say what P1 up or down actually are. I think we need to keep plowing through because I don't think I'm going to quickly figure out what this formula is actually doing. I would like to know, but they don't really tell you. Probably if h is large relative to d, it becomes exponential. Why would that be true? What is... Oh, no, okay, I know what L is. Becomes... It's basically 1 minus u to the n. I don't see how that would... I don't know. It's independent of the turnover rate. You told a person to find 10 hot girls' body structures and find out the equation of curves, superimpose them to find out the nature of those curves. Told cool idea. How would you do it? I told no idea. Studying like yeah, I don't know how you would do that either. There's a lot of non-math stuff in the this is a gorilla song on Melancholy Hill. It's pretty good so far. Melancholy. Is that how you spell gorillas? Yeah, it is. Okay. Came a little late. What's H here? H. I had the same question. What was H again? H is the drug-induced death rate. Each my saying you feels like a radioactive decay equation. It can also be used for that. This is the probability of treatment failure. In this case, of cancer when you use a single drug. Like a Poisson slash count model? Oh yeah, yeah. Oh, honestly, I haven't listened to it since the last time we listened to it on stream. That is non-zero though, right? Tizzer, you can try me. I can't promise with physics, but if you want, you can post it and I can tell you yes or no. In the context of a single drug, high and low turnover cancers behave in exactly the same way so far as the preexistence of mutants is concerned. Which does sound unintuitive, right? You would think a high turnover cancer has more mutants. It has more chances for mutations. Your intuitive explanation is as follows. A higher turnover cancer requires more cell divisions to reach size n, and thus more mutants are created. At the same time, however, the death rate of the mutants is also increased. Okay. The two effects cancel each other out. Huh, okay. Fair enough. Similar behavior is observed numerically in reference 15. The contribution of the treatment phase can be ignored. And the occurrence of treatment failure is not influenced by the efficacy of the drugs. Interesting. Let's see what Tizzer is posting. In fairness, I dual stream to Twitch and YouTube, so if you hear me talking to someone who's not in the chat that you're looking at, that's why. The chats are combined up there. You'll figure out I'll find the equation where you write a book, Sexy Equations. You know what? You live your dream. If that's what you want to do, you should do that. At the base of a vertical cliff, a model rocket starting from rest is launched upwards at t equals 0. The time-varying acceleration given by a(y) of t is equal to a minus bt. This height is higher than the maximum height reached by the rocket. This height h is higher. Oh, no. I don't know what this sentence means. Did I miss a chat? Oh, I missed a chat. Ha, that explains it. That might have been my bad. I missed one of your lines. There we go. What is this nice dreamy music? Oh shoot. Back up. Waltzing back, no vacation. And this is the playlist. If I can find it. Yeah, I wish I could set up an automatic like exclamation point song command, but it's not really possible with how my music currently is set up. Okay, yeah, Tizzer. Sorry I missed that line. Sounds good, Coral. I'll probably try and work through it for myself here, but you're welcome to do that if you want. Okay, A and B are positive constants. Also at t equals 0, small stone is released from the top of the cliff at a height h directly above the rocket. This height h. Yeah, I've been enjoying this one. It's just like Spotify radio too. Just set for a good song. You said this 12 years ago? Okay. T equals 0, small stone is released from rest from the top of the cliff at a height h directly above the rocket, higher than the maximum height reached by the rocket. The stone hits the rocket at the instant when the rocket reaches its maximum height. Venlux, you did call it that there's a rock being dropped. Gravitational acceleration magnitude g is downward, determine the expression initial height h from... Oh, because of this part. Okay. Why do we need to be at the base of a cliff? Oh, I guess because we're dropping the stone. Okay. Cliff? I want a bigger cliff. I don't remember a problem like this. Maybe. That's a crappy rocket. That's a slightly less crappy rocket. That looks like a dick. Or no, it looks more like the Washington Monument. How do you draw a rocket? It just looks like a dick. There. I don't know. I'm drawing this rocket way too big relative to the cliff also. Oh my god. You know what? It's a point. The rocket is now a point. This is physics. Rockets can't help but look like dicks because they're all dick-shaped. That's true. Some rockets are more dick-shaped than others. Just ask Jeff Bezos. The thing we really care about is the very, like, top of the rocket anyway, because that's what hits the rock. It's a model rocket, though, so, like, we're saying the rocket is small. I guess the acceleration at any time for the rocket? It starts accelerating up, and then accelerates down? Yeah, I guess that makes sense. Height h is raised from rest at t equals 0. Okay. So h is the entire distance here that the rock is dropped from. There's an image? Oh, I guess I'm able to figure out what's happening. I think we'll be okay. That's good to know, though. Place just continually fire. Who is? This is Mr. Kitty, the same person who did the song. %, angel. Okay, so yeah, I guess integration. So I think we're just gonna find. We can find the time that they collide. Oh, this is annoying. Okay, let's start by finding the maximum height of the rocket. That's an important thing for this question. I think it's probably the first thing we should work on. I think the quick and dirty way of doing this is to let the acceleration be 0. Oh, really? I don't know anything about the artist. That kind of sucks if that's true. Um... Wait, ooh, is that true? Acceleration isn't 0 at max height. Velocity is 0, right? Acceleration is no. Yeah, I'm doing this wrong. So we need velocity to be 0 for maximum height. So we need to integrate acceleration. BT squared plus C. Galois theory, welcome in. Also, welcome in, Tiny Spider Dancer. Unrelated, but any advice on grad school, master's, eventually PhD in the U.S. applications, also U.S. citizen? I would say identify the weaknesses in your application And do your best to cover for that with your personal statement. Can't leave us open on Twitch. I can believe it. So I just started a master's in applied math, and the main weakness of my application in my mind was my transcript. I had good grades. I did not take very challenging classes though. Hey, it's better. And so I tried to address that by talking about actually the stream and all the studying that I've been doing since graduating with my undergrad degree. And so I think it's maybe like the number one thing. I had a second weakness in my application, which was a recommender said yes to writing me a letter and then never followed through. That one couldn't really be helped because it was last minute, but I also had that weakness in my application. The algebra professor was the GOAT? Nice. Hence the username, I guess. So I think that's probably like the number one thing. I wasn't able to do this, but if your goal is for a PhD, it is good to try to have some idea of what you'd want to research. It's something that I tried to address in my application. I don't think I did a very good job of it. But if you can show that you have some kind of like, I guess concrete-ish interest in research, I think that helps too. Especially if you can tailor it towards like what the professors there are researching. I think that helps. Yeah, that's what comes to mind at least. If you have any like specific thing that you're curious about, let me know. We do know that the rocket starts from rest, so the constant is just 0. And so now this is our velocity. The maximum height happens when velocity is 0. So we're going to take that set equal to 0. Ooh, that's a good question. That depends on the school. So I did applied math, and the places I applied to either would not accept it or it was optional. So I did not do the math subject GRE at all. But for pure math, I bet it's more important. With COVID, they stopped requiring it too a bit, and they're starting to bring requirements back. That's something where you should look up schools you're interested in potentially applying to and see what they say. Because for me, it did seem pretty varied. You can probably get away with not doing it, but if you feel confident in the stuff that it tests, it's going to help you, I think. Because like with applied math, the math GRE, it really isn't. It's mostly about pure math. So for someone who's interested in pure math, it's probably more helpful. Yeah, no worries. Thanks for the questions. And if you have more, feel free to keep them coming too. But good luck with your applications. It's not easy to go through that process. So at t equals 2a over b, that's the time we reach the maximum height. So there's kind of two pieces of the puzzle now. We need to figure out how far the rock traveled in that time. And we need to find out how far the rocket traveled in that time. We add those two together and we get h. Can I re-explain? Yes. So my strategy for solving this problem is to start by finding the maximum height of the rocket, the time that happens. And so I do that. We know the acceleration of the rocket in that it starts from rest. So I hope you know calculus. And I didn't just use something you're not allowed to use. But velocity is the integral of acceleration. So we can take the acceleration function and integrate it. Yes? Okay, good. And we get that the velocity is at minus 1/2 bt squared. And so when the rocket is flying up, it eventually reaches the maximum height, and for an instant in time, it's at rest. And then it starts coming back down. So the velocity is 0 at the maximum height. That's the property that I'm using here to find out when the max height happens. So we take the velocity we just found, set it equal to 0, and solve for t, and that's the time the rocket reaches its max height. Let's go through the applications process too, hopefully. Oh, that's right, yeah. Good luck to you as well. And so if you do that set equal to 0 and solve for t, you get 2a over b. And so that's reason to take 0. Because at the maximum height, the rocket is temporarily at rest just for an instant. Because its velocity starts as positive, it slows down, and then for an instant, the velocity is 0, and then it becomes negative and falls down to the ground. So when velocity is 0, it's at the maximum height. That's why I said it equal to 0, because we want the maximum height. So just remembering that the maximum height occurs when velocity is 0. Not sure yet what I'll study. I still have someone who will be my supervisor. Right? Yeah, sounds like you have an in there. What if it's a master's in design or has enough of a design component? That's fair. Yeah. I think some universities are pretty good about having like interdisciplinary programs. I wonder if you can make something like if you're interested in something else, you could maybe still involve design in that somehow. Okay, you see, that's good. Okay, so the next part of the problem is we know that the time this happens at. So all we need now is to know how far the rock travels in that time and how far the rocket travels. This is weird phrasing, rock and rocket, but how far each of these two things travel in that time. And that gives us the entire height. So that's going to be the next phase. So we'll start with distance traveled by the rock. The rock's acceleration is just negative gravity. And so now we're going to use integrals again. Minus g dt. So we get minus gt plus some constant. The rock starts from rest though. Yep. So the constant is 0. So I'll just erase that. Now the position is the integral of velocity. Sorry, the integral of velocity, and velocity is minus gt. dt. So it's minus 1/2 gt squared plus c. The rocket starts from rest. It was weird. I had to look at the question to confirm that. They say the model rocket starts from rest. It does accelerate immediately, which is weird. But I think we still count it as from rest. Oh shoot, I missed Gawal Theory's last message there. I took a break after my undergrad for 2 years. I'm trying to get back. I miss it too much. It makes you feel any better. My break, I graduated with my undergrad 7 years ago, and I only just started my master's a few weeks ago. I did have the advantage of having done this stream for 2.5 years now, so that helped me get back up to speed with math. But definitely when I first started this stream, it was a little bit rough on the math front. Now, this constant, we don't know the rock's initial height. That's the thing we're trying to solve for. Your undergrad took 15 years? Did you have a break in there, or like, were you like just trying your heart out and it still took that long? No like judgment or anything, but like, that's really long. This plus C, there's a way that we can deal with it. I'm trying to phrase it right. You switched majors a couple of times and took a 4-year break. That'll do it. That makes sense. Especially if they're completely different majors too. FA, you fill a much needed gap. That's not a bad fortune. I took about 9. Wow. That's wild. Gonna try and go back for another degree in your 60s? Nice. In physics? $10? It spanned 15 years. Yeah, that makes sense. So the thing we care about with the rock is the change in position. So because that's what this distance here is. That's the thing that we're after. So I'm going to take like y final minus y initial. And I'm doing that because of this plus c issue here. So the final y is y of t evaluated at this time when they collide. 1/2 g 2a over b squared plus c minus initial y is y of 0, which is just c. Lobster, hello. Hope you're doing well. Physics, yeah, why not? Fair enough. Wait until it's free, or I'm independently wealthy, whichever comes first. Okay. I mean, at the community college, I guess they might offer like a 4-year physics degree. Okay, and so the c's cancel out, thankfully, because we don't know what to do with c yet. So 4a squared over b squared minus, simplifying things a bit, 2g a squared over b squared. So that's the distance the rock travels. The sign isn't too important. It just drops by that much y, but we don't care about that necessarily. Going from English literature to linguistics to cognitive science. So a fair amount of overlap with linguistics and cog sci, but basically no overlap with English literature. Yeah, I bet. Took a lot of biology. Fair enough. I thought linguistics will be cool. Yeah, I can see that being like a pet, like side hobby, I guess. I know that Ian Stuckey likes linguistics. Okay, so that's the distance that the rock travels. The last piece of the puzzle is the distance the rocket travels. This is a long question. So we get the distance the rocket travels. Why am I copying that? By integrating velocity. That's the equation we found for the velocity of the rocket. So we'll get 1/2 AT squared minus 1/6 BT cubed plus another constant. The rocket starts at height 0 though, so this constant is 0. Now we want to know what the height is at 2a over b. Nope, 2a over b, not 0. This is not going to be a very clean answer. I assume we have a common denominator, right? With the b's, at least. 2a cubed over b squared minus 4a cubed over b squared 3. And then this is, multiply that by 3 over 3. So we get 2a cubed over 3b squared. Yes. Distance traveled by the rocket part? Okay. Thank you for letting me know. The distance traveled by the rocket, I took the equation we found for the rocket's velocity, at minus 1/2 bt squared, and I integrated that again, because now we want the position. So you integrate velocity to get position. And so that's what this first step here is. Once we know the position of the rocket, we can plug in the magic time that we found in the first part, 2a over b, to find the distance the rocket travels. So I took this, plugged in 2a over b, and now I simplified it down to this thing here. Also, I'm neurodivergent. My reading speed is in the 8th percentile, so that adds time. Oh, fair enough. I never had my reading speed, like, I didn't know that they, like, measured it like that. I bet I wouldn't be very good either. I find myself having to reread things a lot to understand them. But nowadays you can get apps to read PDFs to you. Probably. You can choose a nice sexy voice too. Be distracting. Depends on the choice of literature, I guess. For acceleration, you need to add a minus g term, no? That's what I felt like, Coral, but they say that the acceleration of the rocket is a minus bt, and so I'm taking them at their word there. Or if nothing else, you could argue that a could have a hidden g inside of it. It is just a constant like g. I think the difference, for that reason, the difference isn't big. I do think they mean that it's the net acceleration to Fembox. But even if it wasn't, I think we do already have a constant in here. And I guess G is negative. They say A is positive. I'm thinking it's net. I don't feel bad, Coral, but yeah, I was wondering about that too. Like, I was about to make the same mistake. Just like I paid to assess me for ADHD, I also test my reading speed and a bunch of other things, IQ and whatnot. Oh, interesting. I didn't know that, like, that'd be all that relevant for ADHD. I guess it's probably hard to diagnose it, though. You probably need a bunch of random data points like that to help you make up your mind. Yeah, it's exactly it. What you need to do is relatively straightforward, but it takes a lot of work. Chess, I like watching chess. I just played chess on stream the other day, but it's not something I do. I don't play it super frequently. Oh no, 2 pages, all the explanations. Oh, I'm sorry. All right, so Tizzer, I hope that you understand this part now. Let me know if you still don't, or if this part that you still have a question on. Because we're ready to get the final answer, which is, you do? Great. I'm just going to type this. So total height equals distance traveled by rock plus distance traveled by rocket. And I'm going to take, like, we found a negative distance here because it dropped, but I'm just going to make it positive because we want to do this distance plus this distance, so. So travel by rock, 2g a squared over b squared. Two a cubed, 3b squared. And so that's technically the answer there. I guess we can simplify this. It doesn't get all that simpler, but 6g a squared plus 2a cubed over 3b squared. So, like, this answer is kind of ugly, but I think it is the answer. You want to solve it graphically, but you're too lazy to do it? Yeah, I mean, a graphing calculator makes the issue is that we don't know where the constants are supposed to be. Without G, grab the rocket and the stone, the problem probably becomes easier because you could change the reference frame to follow G as well. Ooh. That's an E, yeah. The formatting of that got a little mangled, Tizzer. Doesn't look too far off, though. Like, I could factor an a squared out for my answer on top here, and it looks kind of similar to a chunk of what you have there. So yeah, let me know if this doesn't match, because what you put there in chat isn't making sense. I like it. If any of these 3 things match. Check dimensions. Oh, yeah, true. A is acceleration, B is velocity? No. Meters per second cubed. I'll use this here. Ooh. S to the fifth? I think it's not matching. Are you sure? This term is problematic, isn't it? Well, also, everything is problematic. We got problems. You think I'm getting, oh. The seconds definitely are not canceling. Think you know it? Anvil by Lorne. The seconds need to cancel and they aren't. I have to watch the music video. See, with this problem, I think I did make a mistake somewhere. It's such a long problem that I really don't know where. I'm curious to watch this music video, but well, so maybe I'll check dimensions on this thing instead. Meters per second, meters squared, seconds to the fourth. I mean, wait. A is meters per second squared. B is meters per second cubed. Meters squared. Seconds to the 6. Meters cubed. Seconds to the 6. Meters squared. Second to the 6. This is just meters. That's good. This... It's like seconds times meters or something like that. This is s to the 5th. That's s to the 6. G is ms squared. Oh my god. Oh my god, it is right. Tizzer, I take that back. I think I'm right. Thank you, $10. That needs to be the last problem of the day. We will look at this music video though. So yeah, Tizzer, I take that back. I think I'm right. Let me know if you have any questions about that. I'm gonna watch this video and probably wrap things up. Reacting on stream. Yeah, the time flew by here, Femvox. I didn't. It doesn't feel like it's been 6 hours. This animation style is really cool. This is some Matrix stuff. Oh, she's a robot? I don't know. Ooh. Damn. That is that is a cool video. I quite like music videos, and that's a really unique one. Good call on that, Fembox. On that note, that's going to be the end of the stream for today. So yeah, I'm gonna cut the YouTube stream off here. On Twitch, we'll look for a raid. So Tizzer, anyone else who's here on YouTube, thanks for being here.